Have you ever looked up at a clear, star-studded sky, feeling the solid earth beneath your feet, and wondered how you are actually hurtling through an infinite void at hundreds of thousands of miles per hour? It is a beautiful contradiction, a gentle paradox that challenges our everyday perception of reality. We experience our lives in a state of apparent stillness, surrounded by the quiet comfort of our familiar world. Yet, we are inexorably bound to a cosmic dance of staggering proportions. The universe is filled with these magnificent illusions, where the silence of the night sky masks a reality of unimaginable scale and ancient motion. Tonight, I invite you to join me on a contemplative journey far beyond the boundaries of our terrestrial home. We are going to venture into the deepest layers of the cosmos to encounter a mystery that stretches the very limits of human comprehension, a structure so incomprehensibly massive that it will forever change how you perceive our place in the dark. The biggest galaxy we have ever discovered is so large that your brain will struggle to truly understand it. This is not an exaggeration, nor is it dramatic storytelling. It is the honest truth about a cosmic monster that sits over 1 billion light years away from us, quietly existing in the darkness of space, holding more stars than you could ever count in 1,000,000 lifetimes. Hello, I am Theodore, the researcher. As we prepare to step further into this endless cosmic sea, I noticed that 71% of the people who join us on these contemplative explorations have not yet subscribed to the channel. If you find peace and wonder in these journeys through the universe, please consider subscribing. It truly helps us continue to craft these stories and ensures that we can keep exploring the deepest mysteries of space together. Now, take a deep breath, relax, and let us return to the stars. If you are anything like me, you probably thought you understood how big things could get in space. You have seen the pictures of Jupiter dwarfing Earth, and you have heard how our sun could fit 1,000,000 Earths inside of it. You might have even wrapped your head around the fact that our Milky Way galaxy stretches across 100,000 light years from one side to the other. But all of that, every single comparison you have ever heard, becomes almost meaningless when you learn about what astronomers found hiding in a distant corner of the universe. To truly grasp the magnitude of this discovery, we must first ground ourselves in the familiar. Our home, the Milky Way, is what scientists call a barred spiral galaxy. It possesses beautiful curving arms made of stars, gas, and dust, all swirling around a central bulge where an enormous black hole sits in silence. From one edge to the other, our galaxy measures roughly 100,000 light years across. That means if you could travel at the speed of light, the fastest anything can move in our universe, it would still take you 100,000 years to cross from one side to the other. 100,000 years is longer than modern humans have existed. It is an expanse of time, far longer than the period since we first learned to paint on cave walls, longer than every civilization that has ever risen and fallen on Earth combined. Yet, that immense span only represents the width of our own little corner of the cosmos. The Milky Way is a bustling metropolis of light, home to somewhere between 200 billion and 400 billion stars. Each of those glowing ancient spheres might have planets orbiting around them, moons circling those planets, asteroids tumbling through space, and comets streaking through the void. Our sun is just one of those hundreds of billions of stars, sitting about 26,000 light years from the galactic center in a quiet neighborhood called the Orion Arm. Suspended in the vastness, our sun and its planets orbit the center of the galaxy at a staggering speed of about 500,000 miles per hour. Even at that tremendous velocity, it takes our solar system about 250 million years to complete a single lap around the galactic center. Astronomers sometimes call this incredibly long period a cosmic year. To put that gentle, sweeping motion into perspective, consider that in the entire time dinosaurs roamed the Earth, our solar system did not even complete one full orbit. The last time our sun was in roughly this position, looking out at the same starry neighborhood, the most complex life on Earth consisted of simple marine organisms floating in primordial seas. That is how vast even our own galaxy is, a slow, majestic carousel carrying us through the depths of time. But even with hundreds of billions of stars, the space between them and the Milky Way is almost unimaginably empty. Our nearest stellar neighbor, a small red dwarf called Proxima Centauri, is about 4.24 light-years away. That distance is so breathtakingly great that if you shrunk the sun down to the size of a single grain of sand, Proxima Centauri would be another tiny grain of sand, sitting about 4 miles away. The space in between those two grains would be essentially a void, holding just the faintest whiff of gas and dust and the occasional solitary particle of cosmic radiation. This profound emptiness is a mystery that is hard to wrap your mind around when you live on a crowded planet surrounded by billions of other people. We are completely used to density, to things being close together. But the moment you step outside our solar system, emptiness becomes the undeniable rule of reality. Stars are separated by such vast, silent gulfs that the chance of any two of them colliding by accident is essentially zero. Entire galaxies can pass straight through each other like ghosts without any stars actually hitting one another. Yet somehow, even in all that endless emptiness, there is enough stuff out there to make hundreds of billions of stars in our galaxy alone. The gas and dust between the stars may be incredibly sparse, but when spread out across thousands of light years, it adds up to enormous amounts of life-giving material. Because of this, new stars are forming right now in giant molecular clouds scattered throughout the Milky Way. Beautiful, glowing nurseries where gravity has gently pulled enough ancient gas together for nuclear fusion to ignite. When you venture out to a dark location and look up at the night sky, that hazy, ethereal band of light stretching overhead is actually the combined, distant glow of billions upon billions of stars residing in our own galaxy. Ancient people, looking up in awe, thought it looked like spilled milk flowing across the heavens, which is precisely where the name Milky Way comes from. For most of our human history, we simply assumed that this glowing band was everything that existed, thinking our galaxy was the entire universe. Different cultures wove different, beautiful explanations for that celestial river of light. The ancient Greeks told mythological stories of milk spilled from the goddess Hera's breast, while the Romans romantically called it the Via Lacta, translating to the Milky Road. In India, it was revered as the sacred path that souls take on their final journey to the afterlife. Aboriginal Australians, deeply connected to the land and sky, saw it as a grand river flowing through the heavens. People throughout all of history have looked up at that exact same band of light, felt a profound sense of connection, and wondered what secrets it might hold. When the first telescopes were finally turned toward the Milky Way in the 17th century, dedicated observers began to realize that the milky glow miraculously resolved into countless individual stars. It was not until the 1920s, however, that a brilliant astronomer named Edwin Hubble fundamentally shifted our understanding of existence by proving that those fuzzy smudges people had been observing were actually entire galaxies themselves. He showed that each one contained billions of their own stars, and that each one was impossibly, staggeringly far away from us. That single discovery changed absolutely everything we thought we knew about our humble place in the cosmos. Hubble made this monumental discovery while working at the Mount Wilson Observatory in California, utilizing a massive reflector equipped with a mirror exactly 100 inches across. By carefully measuring stars known as Cepheid variables, he calculated that the Andromeda Nebula was roughly 1 million light-years away, though we now know it is closer to 2 million light-years away. Our galaxy, it turned out, was merely one solitary island universe among a vast ocean of many. Today, through the unyielding curiosity of our species, we estimate that there are somewhere around 2 trillion galaxies dwelling in the observable universe, a 2 followed by 12 zeros. Each of those contains billions or trillions of stars, numbers so profoundly large that they invite us simply to surrender to the wonder of the infinite. As we continue our gentle journey deeper into the infinite expanse of the universe, we must pause to consider the magnificent variety that exists within this quiet cosmic ocean. Not all of those 2 trillion galaxies scattered across the dark vastness are created equal, and understanding their subtle differences is absolutely essential to grasping the sheer scale of the breathtaking mystery we are about to unravel. Some of these island universes are tiny, fragile dwarf galaxies containing just a few billion ancient stars drifting peacefully through the endless silence of space. Others are massive, majestic spirals, much like our own Milky Way, or our nearest large neighbor, the Andromeda Galaxy, adorned with curving arms of gas and starlight. And then, sitting at the very extreme end of the cosmic scale, there exist the true behemoths of the cosmos, structures so enormous that they make our entire home galaxy look like nothing more than a solitary speck of dust floating in an empty, darkened warehouse. Before we approach the grandest of these titans, please allow me to reintroduce myself as Theodore, the researcher. I notice that 71% of the curious minds who watch our videos and join us on these contemplative explorations have not yet subscribed to the channel. If you find comfort and intellectual safety in these peaceful journeys, please consider subscribing because it helps us out immensely and ensures we can continue to explore these beautiful cosmic mysteries together. Now, let us return to the quiet darkness of the cosmos. Galaxies come in many beautiful shapes and sizes, each telling a unique story of ancient cosmic evolution. The most common type we observe in the nearby universe are spiral galaxies, much like our own, characterized by their distinctive pinwheel arms and flat, rotating disks. These magnificent structures are typically vibrant sites of active star formation, with new stars constantly being born within the gas-rich spiral arms. The structure is maintained by a perfectly balanced cosmic dance, a delicate equilibrium between the rotational motion of the disk and the relentless gravitational pull of all the matter held within. In contrast, elliptical galaxies represent another major structural type found in the universe. Unlike the graceful spirals, these ancient galaxies possess no particular defining structure. They range from nearly perfect glowing spheres to highly elongated oval shapes, populated almost entirely by very old, quiet red stars. Active star formation in elliptical galaxies has largely ceased, as they have gracefully exhausted most of their available gas supply over billions of years. It is a profound truth that the largest galaxies in the universe are almost exclusively elliptical in nature, formed through the ancient merger of multiple smaller galaxies colliding over billions of years. There are also irregular galaxies which have no defined shape at all, existing as beautiful smudges resulting from gravitational interactions with nearby galaxies. The Magellanic Clouds, visible from the southern hemisphere, are examples of irregular galaxies being affected by the Milky Way's gravity. It is also a profound mystery that galaxies are not merely distributed randomly through the endless silence of space, as one might assume when looking at a chaotic spray of droplets. Instead, they are beautifully organized into much larger, sweeping cosmic structures. Galaxy groups, for instance, are relatively intimate gatherings that contain anywhere from a handful to perhaps a few dozen galaxies. Our own Milky Way belongs to exactly such a structure, known simply as the local group, which contains about 80 known galaxies, beautifully encompassing Andromeda and several dozen smaller, quiet dwarf galaxies. Beyond these intimate groups lie galaxy clusters, which are larger still, containing hundreds to thousands of massive galaxies all inextricably bound together by the relentless force of gravity. And finally, the largest known structures of all are superclusters, vast mind-bending assemblages of multiple galaxy clusters stretching incredibly across hundreds of millions of light-years of empty space. The particular galaxy I wish to guide your imagination toward today is one of those true cosmic monsters, a structure that challenges the very limits of our comprehension. It goes by the somewhat dull, unassuming name of IC 1101, a designation derived simply from its numerical entry in a historical catalog of celestial objects created over a century ago. But I urge you, do not let that seemingly boring name deceive you for even a moment. There is absolutely nothing boring or ordinary about this quiet, ancient cosmic giant. This colossal entity sits majestically at the very center of a massive cluster of galaxies called Abell 2029. This cluster is located in the direction of the constellation Virgo, as seen from our tiny vantage point here on Earth. When astronomers point their powerful telescopes toward this specific quiet region of the night sky, they behold a massive, breathtaking collection of galaxies, all inextricably bound together by gravity, performing an eternal, slow-motion dance around a common gravitational center. And right there, nestled in the deepest heart of that massive cluster, dominating absolutely everything around it, like a silent, ancient cosmic emperor sitting upon an invisible throne, sits IC 1101. The sheer, staggering scale of this galaxy is where the true sense of wonder begins to overwhelm the mind. This single galaxy is estimated to be somewhere around 4 million to 6 million light-years across. I invite you to pause and simply let that impossible number sink deep into your thoughts for a moment. Our entire Milky Way, a structure which we have already established, seems impossibly large to our human perception, is only about 100,000 light-years wide. This means that IC 1101 is roughly 40 to 60 times larger than our entire vast home galaxy. If you were to somehow place IC 1101 exactly where our Milky Way currently sits in the dark universe, it would not merely engulf our galaxy, it would completely swallow our entire cosmic neighborhood without a single trace. The mighty Andromeda Galaxy, which currently sits about 2.5 million light-years away from us across the silent void, would find itself entirely contained inside IC 1101's incredibly massive body. The Triangulum Galaxy, another close, beautiful neighbor of ours, would also be instantly consumed by this unimaginable expanse. All of the dozens of smaller, quiet dwarf galaxies that currently orbit around us, peaceful places like the Large Magellanic Cloud and the Small Magellanic Cloud, would simply become tiny, insignificant components floating within this giant's vast, endless structure. But physical size, as mind-bending as it may be, is just the very beginning of what makes IC 1101 such an incredibly profound mystery of the cosmos. This single ancient galaxy is estimated to contain an astonishing, incomprehensible 100 trillion individual stars. 100 trillion. To place that into our fragile human perspective, our Milky Way has perhaps 400 billion stars at the very most. That extraordinary fact means that IC 1101 possesses roughly 250 times more stars than our entire home galaxy. Imagine, if you will, a quiet, infinite journey where you started counting the individual stars in IC 1101, counting exactly one glowing star per second without ever stopping. It would take you over 3 million entire years just to count to 100 trillion. And that is assuming a reality where you never slept, never stopped to eat, and never took a break of any kind whatsoever. It is a quantity of light and matter that fundamentally defies our earthly common sense, inviting a profound sense of peace and humility before the grand, infinite scale of creation. The fascinating human story of how we first discovered this staggering cosmic giant begins far back in the quiet nights of the year 1790. A German-born British astronomer named William Herschel was dedicating his life to systematically, gently scanning the dark night sky with his handmade telescope. Herschel was widely considered one of the greatest, most curious astronomers of his era. He had already achieved fame by discovering the pale planet Uranus several years earlier, and he spent much of his quiet life meticulously cataloging thousands of mysterious celestial objects that no human eyes had ever documented before. On June 19th of that particular year, Herschel pointed his telescope toward a dark region of the sky in the constellation Virgo and noticed a very faint, fuzzy blob of light. With the methodical care of a true explorer, he recorded its position and simply moved on to the next object in the infinite dark. At that time, Herschel had absolutely no way of knowing what profound mystery he was actually looking at. The human technology simply did not exist to measure how incredibly far away this silent object was. The scientific understanding of the era did not even possess the concepts required to recognize that it was an entire galaxy, completely separate from our own. Herschel simply logged it as another quiet nebula, one of the many mysterious cloud-like objects scattered across the vast heavens. For over a full century, that faint smudge of ancient light remained an absolute mystery to the human mind, hiding its true, monstrous nature in plain sight. It was eventually given the specific designation IC 1101 when it was respectfully included in a massive celestial list called the Index Catalog, which was an expansion of an earlier historic list of beautiful cosmic curiosities. Astronomers studied it when they could, but without the necessary tools to understand its true, mind-bending nature. It remained just another quiet, unassuming entry in a very long list of cosmic mysteries waiting to be unraveled. Everything changed in the 20th century, when curious astronomers developed vastly better telescopes and entirely new, ingenious techniques for measuring cosmic distances. They finally discovered the profound truth that IC 1101 was not a simple cloud of gas residing within our own galaxy. It was an entirely separate, ancient galaxy, mind-bogglingly far away in the infinite dark. The gentle light we see from IC 1101 today actually left that massive galaxy over 1 billion years ago. It has been traveling silently through the vast empty void of space for more than 1 billion years just to reach our fragile telescopes. Think about that quiet journey through the cosmos. When that ancient light first began its unfathomably long journey toward us, life on Earth consisted mostly of simple, single-celled organisms floating in primordial oceans. Complex animals had not yet evolved to wander the land or swim in the seas. The massive dinosaurs would not appear on the Earth for another several 100 million years. Every single major event in all of human history, from the rise of the very first civilizations to the invention of the telescope itself, happened while that ancient, tireless light was still crossing the endless emptiness between galaxies. As we contemplate the staggering journey of this ancient light, please allow me to briefly remind you that I am Theodore, the researcher, and I have noticed that 71% of the wonderful people who watch these videos have not yet subscribed to the channel. If you are enjoying this quiet journey into the mysteries of the universe, please consider subscribing, as it helps us out tremendously and allows us to continue bringing these peaceful cosmic stories to you. Returning to our exploration, as astronomers continued to study the faint light of IC 1101, they began to unravel the mystery of why it had grown to be so incredibly massive. They discovered that this galaxy did not grow to its enormous size through normal, peaceful processes alone. It became an absolute giant through an act of slow, cosmic violence that has been happening silently for billions of years. IC 1101 is what scientists vividly call a cannibal galaxy, meaning it has spent its long life eating other galaxies. To truly understand galactic cannibalism, you need to think about how gravity works on the absolute largest scales of the universe. Galaxies do not exist in complete isolation in the vast dark. They are grouped together in massive clusters, held tightly together by their mutual, relentless gravitational attraction. Within these massive clusters, galaxies move around each other in a slow, majestic dance, sometimes passing close by, sometimes colliding directly over millions of years. When two galaxies get close to each other in the silence of space, their immense gravity begins to gently but firmly distort their shapes. Ancient stars get pulled entirely out of their normal, familiar orbits. Enormous clouds of gas and dust get compressed and stretched across the dark. If the galaxies are relatively similar in size, they might gracefully merge together over hundreds of millions of years, eventually forming a single, larger galaxy in the cosmos. But if one galaxy is much bigger than the other, something entirely different happens in the dark. The larger galaxy simply absorbs the smaller one, stripping away its ancient stars and gas, adding all of that scattered material to its own incredibly massive body. This gentle but absolute consumption is exactly what has been happening to IC 1101 for billions of years. As the absolute largest and most massive galaxy in its cluster, IC 1101 sits perfectly at the gravitational center of everything around it. Smaller, quiet galaxies that wander a little too close become hopelessly trapped by its enormous, inescapable gravity. They slowly spiral inward, getting torn apart and completely consumed over millions of years of cosmic time. Every single meal makes IC 1101 a little bit bigger, a little bit more massive, and a little bit more dominant in its galactic neighborhood. Scientists estimate that IC 1101 has undergone at least 76 major mergers over its long ancient history. 76 separate times, another substantial, magnificent galaxy fell into this quiet cosmic giant and was entirely absorbed into its growing body. And those are merely the major mergers. Countless smaller, fragile dwarf galaxies have also been consumed over the eons, galaxies so incredibly small that they barely registered as a meal for this enormous silent predator. The undeniable evidence for this cannibalistic history is written directly into IC 1101's very structure, When you look at a beautiful galaxy like our Milky Way, you see a magnificent spiral pattern. Those graceful spiral arms are vibrant regions where stars are actively forming, where immense clouds of gas are gently collapsing under gravity to create new, glowing stellar nurseries. Spiral galaxies have lots of gas and dust, which are the raw materials strictly needed for star formation, and they possess a distinct, rapidly rotating disk shape. IC1101 looks absolutely nothing like this familiar structure. It is what astronomers call an elliptical galaxy, which means it has a smooth, oval-shaped appearance with absolutely no spiral arms to speak of. Elliptical galaxies usually form when massive spiral galaxies merge together in the vastness. The violent gravitational interactions that occur during a merger completely destroy the delicate, beautiful spiral structure, mixing all the billions of stars together into a more random, spherical, or oval distribution. The fact that IC1101 is such an enormous elliptical galaxy tells us that it has experienced so many collisions that any original spiral structure it might have once possessed has been completely and forever erased from existence. All of those ancient collisions, all of that slow gravitational chaos has stirred up the trillions of stars exactly like someone mixing ingredients in a massive cosmic bowl. What remains today is this incredibly smooth, featureless giant, serving as a silent, majestic testament to billions of years of galactic consumption. But there is something even more remarkable and melancholic about the mystery of IC1101. Despite containing an incomprehensible 100 trillion stars, it is actually a dying galaxy. The stars within it are almost entirely old. Most of them are what astronomers call red giants or yellow stars, ancient stellar objects that have already burned through most of their precious nuclear fuel. Very few new stars are currently being born inside the vast expanse of IC1101. This realization might seem profoundly strange at first glance. With so many stars and so much mass gathered in one place, you might reasonably expect IC1101 to be a vibrant hotbed of stellar activity. But you must remember exactly how it grew to be so impossibly large. Every single time it consumed another galaxy, it also greedily consumed that galaxy's entire gas supply. Gas is the absolute fundamental fuel required for star formation in the universe. Without vast clouds of cold gas, new stars simply cannot be born in the dark. Over billions of years of relentless cannibalism, IC1101 has used up or violently expelled almost all of its available gas. The massive mergers themselves were often violent enough to heat the surrounding gas to extreme temperatures, making it expand rapidly and escape the galaxy entirely, or, alternatively, to compress it so quickly that it all formed into new stars at once in brief, intense bursts of brilliant activity. Either way the process unfolded, the tragic end result is exactly the same. A massive galaxy that has completely run out of raw material. What remains now is a quiet, ancient giant slowly fading into the eternal cosmic night. The stars that exist there right now will continue to shine their gentle light for billions of years to come. But as they inevitably, eventually burn out and die one by one, there will be absolutely no new generations of stars to replace them. IC1101 is very much like an ancient, magnificent kingdom that has successfully conquered all of its surrounding neighbors, but sadly has no children left to carry on its glorious legacy. It is undeniably massive, unimaginably powerful, and utterly magnificent to behold. But it is also steadily approaching the final end of its active life, transforming into a silent monument, floating in the infinite void. At the very heart of IC1101, however, lies something even more incredible and terrifying than the massive galaxy itself. sitting directly at the center of this cosmic giant, hidden in the dark, is one of the largest known supermassive black holes in the entire known universe. We know that practically every large galaxy harbors a supermassive black hole at its core. Our own beautiful Milky Way has one called Sagittarius A star, which contains roughly 4 million times the mass of our own Sun. The black hole sitting at the center of the Andromeda Galaxy is considerably bigger, containing somewhere around 100 million to 200 million solar masses. But the silent monster residing at the center of IC 1101 is in a completely, terrifyingly different category of existence. Scientists estimate that this single black hole contains somewhere between 40 billion and 100 billion times the mass of our Sun. To put that staggering number into proper perspective, this single, solitary black hole might possess 25,000 times more mass than the supermassive black hole at the center of our entire Milky Way galaxy combined. Let me try to help you gently understand just how massive this hidden object truly is. If you could somehow weigh the entire Earth, with all its mountains and oceans, you would find it has a mass of about 6 trillion kilograms. That sounds like a tremendously large number until you compare it directly to our Sun, which is roughly 330,000 times more massive than the Earth. Our Sun is a fairly ordinary, medium-sized star, neither particularly large nor particularly small by the grand stellar standards of the cosmos. Now, imagine multiplying the Sun's entire mass by 50 billion. That is roughly how much matter is packed into the supermassive black hole sitting quietly at IC 1101's dark center. All of that inconceivable mass is crushed and compressed into a terrifying region of space from which absolutely nothing, not even a single photon, can ever escape. The gravitational pull at the event horizon, the invisible boundary of the black hole, is so utterly intense that even light itself cannot break free from its grasp. The sheer size of a black hole's event horizon depends entirely on its total mass. For a supermassive black hole possessing 50 billion solar masses, the event horizon would have an astonishing radius of roughly 150 billion kilometers. That might sound enormously large, and it undeniably is. But remember that this is a region containing 50 billion times the mass of the Sun, compressed into what is essentially a microscopic point of infinite density at the very center. The event horizon is just the point of no return, the boundary beyond which escape becomes an absolute physical impossibility. To put this staggering radius into perspective, our entire solar system, from the Sun all the way out to the orbit of Neptune, is only about 9 billion kilometers across. The event horizon of IC 1101's central black hole is roughly 16 times larger than our entire solar system. If you were to gently place this enormous black hole exactly where our Sun is currently located, its event horizon would extend well beyond the distant orbit of Pluto, completely and silently engulfing absolutely everything we consider to be our cosmic home. What exactly would it be like to exist near this monstrous silent black hole? The physics governing such extreme, hostile environments is utterly bizarre and profoundly counterintuitive to our earthly minds. Time itself, the very fabric of how we experience existence, would pass differently near the event horizon compared to someone floating safely far away. Someone tragically falling toward the black hole would look out and see the outside universe vastly speed up, as if watching a movie in fast forward. Meanwhile, an outside observer safely watching the falling person would perceive them slow down dramatically and appear to completely freeze just as they approach the invisible horizon, From the outside perspective, they would never seem to actually cross the boundary into the dark. Inside the event horizon, the rules of reality break down entirely. All possible directions lead inevitably and inescapably toward the singularity lying at the center. Space and time themselves become so horribly warped that the very concept of escaping becomes physically meaningless. The central singularity, theorized to be a point of truly infinite density, would mercilessly tear apart absolutely anything that fell into it, stretching it into impossibly long, thin strands through a violent process that physicists have playfully nicknamed spaghettification. But here is something truly remarkable and surprisingly peaceful to contemplate. Despite its enormous size and terrifying destructive properties, the monstrous black hole at IC 1101 center is currently existing in a relatively quiet state. It is not currently actively devouring huge, chaotic amounts of matter. There is absolutely no brilliant, blinding accretion disk swirling violently around it. There is no incredibly powerful jet shooting out into the dark space at nearly the speed of light. The supermassive black hole is simply sitting there, waiting patiently in the dark. But it has already consumed almost all of the available material that was easily within its gravitational reach. This profound quietness is actually deeply related to the exact same phenomenon that has tragically stopped IC 1101 from forming new stars. Most of the cold gas in the vast galaxy has already been completely used up over the eons, and without a fresh supply of gas falling inward toward the galactic center, the black hole simply has very little left to eat. Occasionally, an ancient star might wander just a little too close and get violently torn apart, providing a brief, brilliant meal for the waiting monster. But these dramatic feeding events are increasingly rare in the dying galaxy. The supermassive black hole, much like the giant elliptical galaxy that faithfully hosts it, is now effectively a giant existing in silent repose, unimaginably powerful but entirely dormant. Even in its current state of profound peaceful slumber, there are still magnificent, ghostly traces of the supermassive black hole's incredible past activity written directly into the very fabric of the ancient space surrounding it. When astronomers peer deep into the cosmic dark, they have successfully detected a faint, lingering radio source emanating directly from IC 1101's silent center, a quiet emission meticulously catalogued as PKS 508 plus 059. This fascinating radio emission comes from what scientists call relativistic jets, which are unimaginably powerful streams of energized particles that were violently accelerated to nearly the absolute speed of light and ejected from the immediate vicinity of the hungry black hole. These colossal, ancient jets are powerfully driven by the black hole's dizzying rotation and its incredibly intense, twisting magnetic fields. As these massive streams of energy shoot out into the silent void, they possess the sheer power to carve out truly enormous cavities in the surrounding clouds of ancient gas. When we look at detailed images captured by advanced X-ray telescopes, these massive cavities become beautifully and clearly visible. They appear as immense, hollow bubbles of very hot, very thin gas that have been forcefully blown outward by the staggering energy released near the central black hole. Some of these quiet, glowing bubbles are millions of light years across, standing as a silent, majestic testimony to ancient, chaotic periods in the deep past, when the supermassive black hole was vastly more active and voracious than it is in our current era. The sheer amount of pure energy fundamentally required to inflate these colossal cosmic bubbles is absolutely staggering to contemplate, roughly equivalent to the total combined energy output of billions of individual stars continuously shining over millions of years. This intricate, delicate kind of energetic feedback flowing between supermassive black holes and their massive host galaxies is currently one of the most active, fascinating areas of deeply contemplative research in all of modern astrophysics. Scientists now deeply believe that supermassive black holes play an absolutely crucial, fundamental role in regulating both the growth and the long-term evolution of the galaxies they inhabit. When immense clouds of cold gas begin to flow inward toward a galaxy's dense center, drawn by the irresistible pull of gravity, the central black hole can awaken and release more than enough energy to drastically heat that surrounding gas and push it outward. By heating the gas so intensely, the black hole effectively prevents it from completely collapsing and forming new generations of stars. This profound mechanism creates a kind of brilliant cosmic thermostat effect, a delicate physical balance that ultimately helps determine the final monumental size and the specific properties of the largest galaxies in the universe. In the specific melancholic case of IC 1101, this ancient feedback cycle may be largely responsible for the giant galaxy's current dormant state. The central black hole has effectively helped shut down all future star formation by continually heating the available gas and completely preventing it from cooling down and collapsing into new stellar nurseries. In a beautiful, poetic sense, the giant galaxy and its giant black hole have finally reached a kind of peaceful, eternal equilibrium, each magnificent entity having slowly shaped and molded the other over billions of years of shared, intertwined cosmic evolution. To fully appreciate this silent giant, we must gently explore the unimaginably violent, chaotic process by which black holes actually grow to such monstrous proportions over the eons. Black holes primarily grow by relentlessly consuming the scattered matter that unfortunately falls past their event horizons. However, when two entire massive galaxies merge together in the dark, the supermassive black holes residing at their respective centers eventually, inevitably find each other and merge as well. Over the course of IC 1101's incredibly long, ancient history of relentless galactic cannibalism, its central black hole has been continuously fed again and again. Every single time IC 1101 consumed another wandering galaxy, it naturally added to the total mass of this constantly growing monster in the dark. Every major and minor merger brought in fresh, abundant fuel for the black hole's seemingly insatiable appetite. The physical process by which two supermassive black holes eventually merge is both profoundly fascinating and staggeringly violent. When two vast galaxies first collide, their central black holes do not immediately find each other in the ensuing chaos. Initially, they remain separated by vast, dark distances and are completely surrounded by billions of swirling, panicked stars. But as the slow, majestic merger progresses over hundreds of millions of years, gravitational friction dynamically interacting with the surrounding sea of stars causes the two black holes to slowly, inevitably spiral toward the exact center of the newly combined galaxy. Eventually, these two absolute monsters of gravity get close enough to form a terrifying binary system, locking into a tight, inescapable orbit around each other in the silent depths of the galaxy's core. As they orbit endlessly in the dark, they continuously lose orbital energy through the emission of gravitational waves, which are actual physical ripples traveling through the fundamental fabric of space-time itself. These invisible, ghostly waves carry immense amounts of energy away from the binary system, which naturally causes their shared orbit to progressively shrink over time, The two black holes spiral closer and closer together, orbiting faster and faster in a deadly cosmic dance, until finally they merge completely in a sudden, catastrophic event that abruptly releases truly enormous amounts of invisible energy. When two supermassive black holes merge, the resulting gravitational waves they produce are easily among the most unimaginably powerful, violent events in the entire known universe. The final climactic merger momentarily releases vastly more pure energy than absolutely all the shining stars in a typical beautiful galaxy combined. Although virtually all of this staggering energy is released purely in the invisible form of gravitational waves rather than visible light. These profound waves ripple outward through the cosmos at exactly the speed of light, literally stretching and squeezing the physical space itself as they silently pass through stars, planets, and even our own distant, fragile Earth. Humanity has only very recently developed the incredible, delicate technology required to directly detect these ghostly gravitational waves washing over our planet. The very first direct historical detection came in the year 2015, when the incredibly sensitive LIGO observatories successfully measured the tiny ripples originating from two stellar mass black holes merging about 1 billion light-years away. Since that monumental paradigm-shifting achievement, dozens of incredible gravitational wave events have been successfully observed, effectively opening up an entirely new, profound way of studying the quiet mysteries of the universe. Future, highly advanced gravitational wave detectors, like the planned LISA mission that will eventually fly in the silent vacuum of space, will possess the sensitivity required to directly detect the massive mergers of true supermassive black holes. When the LISA observatory finally launches, perhaps sometime in the decade of the 2030s, it might actually beautifully detect cosmic events very similar to the ancient mergers that slowly built up IC 1101's central black hole. We will essentially be completely able to listen to this silent universe as giant black holes collide and merge in the dark, adding a profoundly new, almost musical sense to our growing astronomical toolkit. IC 1101's own central black hole has undeniably experienced dozens of such dramatic, violent mergers over its incredibly long ancient history. Each individual merger added immense mass and fundamentally altered the final black hole's rotation and spin. The violent process of these multiple, repeated mergers also profoundly affected the surrounding structure of the host galaxy itself, as the spiraling, merging black holes violently flung countless ancient stars outward through incredibly complex gravitational interactions. This dramatic phenomenon is entirely the reason why IC 1101's massive core is so remarkably large, yet strangely relatively faint to our telescopes. Repeated supermassive black hole mergers have effectively, violently scattered billions of stars completely away from the very center of the galaxy, creating a diffuse core profile that is incredibly unusual for galaxies of this magnificent size. The very presence of such an enormous, quiet black hole sitting in the dark raises deeply fascinating, beautiful questions about the intricate connection between entire galaxies and the sleeping monsters resting at their hearts. Scientists have recently discovered that there is a profound, mysterious relationship between the total mass of a galaxy's central black hole and the overall physical properties of the host galaxy itself. Bigger, more massive galaxies undeniably tend to possess bigger, more massive black holes. But this beautiful correlation naturally invites a profound question. Which of these immense entities actually came first? Did the supermassive black holes form first in the early dark and then slowly grow their magnificent galaxies around them like cosmic seeds? Or did the vast galaxies form first from collapsing gas, and then slowly build up their central black holes over immense stretches of time? The current, deeply poetic answer seems to be that they gently grew together, side by side, each one constantly influencing the long-term development of the other over billions of years. As IC 1101 relentlessly consumed more and more wandering galaxies, its central black hole simultaneously consumed the smaller black holes originating from those unfortunate galaxies. The two destructive processes fed seamlessly into each other, establishing a grand cosmic feedback loop that eventually produced both the absolute largest known elliptical galaxy and one of the largest known black holes in physical existence. The central core of IC 1101 is also remarkably profound for its sheer, uncompromising physical size. A deeply detailed scientific study conducted in the year 2017 using incredibly sharp images captured by the Hubble Space Telescope, meticulously measured the galactic core and discovered that it stretches across nearly 14,000 light-years of empty space. That singular fact means that just the central core of IC 1101 alone, not the entire vast galaxy, but just the innermost region where the black hole resides, is physically bigger than most entire dwarf galaxies drifting through the universe. This single core alone contains vastly more ancient stars than the vast majority of entire galaxies in the observable universe. It stands as a monument of staggering proportions. As we continue to float gracefully through this ancient silent ocean of stars, I want to gently expand our perspective even further outward. IC 1101 is undeniably the absolute largest galaxy of a certain specific type that humanity has ever found hiding in the dark. But the universe is wonderfully full of extreme, breathtaking objects. Understanding exactly where IC 1101 fits into the grand cosmic zoo of galaxies helps us to truly, deeply appreciate just how remarkably unique it is. At one extreme end of the cosmic size scale, we find the quiet, unassuming dwarf galaxies. These are the absolute smallest independent galaxies drifting through the universe, containing anywhere from a few million to perhaps a few billion ancient stars. Our own majestic Milky Way currently has dozens of these fragile dwarf galaxies quietly orbiting around it like loyal, silent satellites in the dark. The absolute smallest of these known companions, a tiny gathering of stars known as Segway 1, contains only about 1,000 stars in total. They are so incredibly faint and diffuse that astronomers did not even discover their quiet existence until highly advanced sensitive sky surveys began in the early 21st century. Yet, despite their tiny size, dwarf galaxies play an absolutely crucial, fundamental role in the grand story of cosmic evolution. They are the essential primary building blocks from which all larger, more magnificent galaxies are slowly assembled over the eons. In the very early universe, when the absolute first primitive galaxies were forming from collapsing clouds of primordial gas, the vast majority of them were exactly these kinds of small dwarfs. These small, fragile galaxies then relentlessly merged with each other over billions of years of silent, gravitational attraction, slowly building up the much larger, more structured galaxies we see today. Every single large galaxy in existence, including our beautiful Milky Way and the monstrous IC 1101, originally started out as small, simple dwarf galaxies that came together in the ancient dark. Moving gently up in physical size, we find magnificent galaxies like the Large Magellanic Cloud, which currently orbits our Milky Way at a safe distance of about 160,000 light-years. The Large Magellanic Cloud contains roughly 30 billion glowing stars and has a total diameter of about 14,000 light years. It is actually visible to the naked human eye from the southern hemisphere of Earth, appearing simply as a faint, cloud-like patch floating in the quiet night sky. But this beautiful neighbor is actually being slowly, relentlessly absorbed by the Milky Way right now. Ancient gas is currently being stripped from it, and eventually, over millions of years, it will merge completely with our own galaxy, adding its 30 billion stars to our growing collection. This is galactic cannibalism in action, happening slowly and silently, right in our own cosmic backyard. Then, of course, we have massive, beautiful galaxies similar to our own Milky Way. Spiral galaxies of this impressive size typically contain somewhere between 100 billion and 400 billion stars, and possess massive diameters ranging from 100,000 to 200,000 light years. They are incredibly common in the local, nearby universe, appearing as beautiful, majestic pinwheels of glowing gas and shining stars. These are places where active star formation continues beautifully even after billions of years of cosmic history. Our nearest large, impressive neighbor, the Andromeda Galaxy, is somewhat larger than the Milky Way. It is estimated to contain roughly 1 trillion stars, perhaps 2 or 3 times as many individual suns as our own home galaxy. Andromeda's majestic, glowing disk stretches about 220,000 light-years across the void, making it roughly twice the physical diameter of the Milky Way. If you venture to a truly dark, quiet location on a clear autumn night in the northern hemisphere, you can actually see Andromeda with your naked, unaided eye. It looks merely like a faint, fuzzy patch of light, but what you are actually witnessing in that quiet moment of observation is the combined ancient light of 1 trillion individual stars, making it the absolute most distant object visible without the aid of a telescope. Beyond beautiful spiral galaxies like Andromeda, we slowly start to enter the terrifying, awe-inspiring realm of the true cosmic giants. Some massive elliptical galaxies resting in the centers of rich galaxy clusters can contain several trillion stars and possess diameters of hundreds of thousands of light years. These ancient, quiet objects are already among the largest, most massive structures in the entire universe. But even they are simply not as extreme, not as incomprehensibly vast as IC 1101. IC 1101 sits completely alone at the very top of this grand cosmic hierarchy. Its 4 million to 6 million light-year physical diameter makes it roughly 20 to 30 times larger than the entire Andromeda Galaxy. Its 100 trillion stars would make it 100 times more densely populous than Andromeda. There simply are not many galaxies in the entire observable universe that can even begin to compare to this silent monster. However, there is exactly one specific category of cosmic object that can surprisingly challenge IC 1101 for the grand title of the absolute largest galaxy, and that is the fascinating family of giant radio galaxies. These are highly active galaxies that feature enormous, violent jets of material shooting forcefully out from their central, supermassive black holes at nearly the speed of light. These powerful jets can incredibly extend for millions of light years deep into empty intergalactic space, making the total physical structure of the entire system far larger than any single collection of bound stars. The absolute most extreme, mind-bending example of this phenomenon discovered so far is a galaxy named Alcyoneus, which was proudly announced to the world in early 2022. Alcyoneus possesses massive radio lobes that incredibly extend across an astonishing 16 million light-years of empty space. That is roughly 3 times larger than the physical diameter of IC 1101, making it the absolute largest known contiguous structure created by any single galaxy in the universe. But here is the critically important fundamental distinction we must make. Alcyoneus's truly enormous size comes entirely from its incredibly long, invisible energy jets, not from its actual collection of stars. The actual physical body of the galaxy itself, the dense collection of ancient stars and normal matter, is quite ordinary and relatively small. It contains only about 240 billion solar masses of stars, vastly less than the 100 trillion stars residing within IC 1101. The majestic radio jets are undeniably impressive to observe, but they are essentially just empty space filled with very thin, highly energetic plasma and twisting magnetic fields. They absolutely do not contain the trillions of glowing stars that make IC 1101 so fundamentally massive and dense. Therefore, when we speak quietly in the dark about the biggest galaxy, we must be very clear about exactly what we mean. If we mean the largest physical structure associated in any way with a galaxy, then Alcyoneus and other giant radio galaxies easily take the prize. But if we mean the absolute largest collection of actual burning stars, the most massive physical body of a true galaxy, then IC 1101 still securely holds the title as the undisputed champion of the known cosmos. There is another deeply profound way to think about physical size that is very much worth our quiet contemplation tonight. Instead of simply measuring diameter across empty space, we could ask the fundamental question, which galaxy actually possesses the most total mass? This turns out to be an incredibly complicated, mysterious question, because the vast majority of any galaxy's total mass is not found in its glowing stars at all. It is hidden away in something mysterious we call dark matter. Dark matter remains one of the absolute greatest, most profound mysteries in all of modern physics. We cannot see it with any telescope. It does not emit any light, nor does it absorb any light that passes through it. It completely refuses to interact with normal, everyday matter in any way, except through the invisible, relentless pull of gravity. But we absolutely know it exists in the dark because galaxies rotate and move in ways that would be physically impossible if they only contained the normal, visible matter we can see with our instruments. Here is the fundamental problem that astronomers face. If you carefully add up all the glowing stars, gas, and dust in a galaxy, and calculate exactly how much gravitational pull they should collectively possess, you get a certain specific number. Then, you carefully measure exactly how fast stars are orbiting in the outer, distant edges of the galaxy, which directly tells you how much gravity is actually present in the system. The two numbers absolutely do not match. There is far, far more gravity pulling on the stars than the visible, normal matter can possibly account for. The widely accepted solution, according to the vast majority of astronomers, is that beautiful galaxies are completely surrounded by vast, invisible halos of mysterious dark matter, an unknown substance that we simply cannot see, but that physically makes up most of the galaxy's true total mass. In a typical spinning spiral galaxy, much like our own Milky Way, dark matter surprisingly accounts for about 90% of the absolute total mass. The brilliant stars, the swirling gas, and the dark dust that we can actually observe and photograph are just a tiny, small fraction of what is truly resting there in the dark. IC 1101, as you might expect, also possesses a dark matter halo, and it is correspondingly, terrifyingly enormous. Scientists currently estimate that the total combined mass of IC 1101 including its vast dark matter halo, could be as high as 1,100 trillion solar masses. That is about 100 times more massive than the entire Milky Way galaxy and its own dark halo. This profound dark matter halo extends incredibly far beyond the visible glowing stars of the central galaxy. While the actual stellar body of IC 1101 is already an astonishing 4 to 6 million light-years across, the invisible dark matter halo likely extends even further into the intergalactic void. Some advanced theoretical models suggest it could reach out for tens of millions of light-years in every direction, making the complete, true structure of IC 1101 and its immediate invisible surroundings truly mind-boggling to contemplate. Understanding the true nature of dark matter is easily one of the biggest, most exciting challenges currently facing physics today. We absolutely know it is sitting there in the dark because of its undeniable gravitational effects on the visible universe, but we still do not know exactly what it is fundamentally made of. Many dedicated scientists deeply believe it consists of some entirely new kind of exotic particle that simply does not interact with light or normal matter, a ghost-like particle that we have not yet managed to detect directly in our laboratories. Huge, highly sensitive experiments are currently underway deep underground all around the world, trying patiently to catch these elusive dark matter particles as they pass silently through the Earth. So far, none have succeeded in capturing a definitive signal. The absolute, undeniable existence of dark matter beautifully shows us that even our current advanced understanding of something as unfathomably large as IC 1101 is still profoundly incomplete. We can see the trillions of ancient stars. We can measure their ancient, weary light. But roughly 90% of what actually makes IC 1101 the massive, dominating giant that it is remains completely invisible to us, detectable only through its quiet, invisible gravitational influence on the universe. There is still so very much we do not know about the dark, silent places of the cosmos. Before we continue to journey further into the profound mysteries of IC 1101, I want to gently guide our focus back to our own fragile world for a moment, to spend some quiet time exploring the remarkable technology and boundless human ingenuity that allows us to even be aware of objects as distant and magnificent as this giant galaxy. When we speak so easily about a galaxy residing over 1 billion light-years away from our home, it is incredibly easy to forget just how monumental a challenge it is to learn anything at all about such distant, silent objects hiding in the dark. The beautiful fact that we know as much as we do today about IC 1101 is a magnificent testament to centuries of relentless scientific progress, human curiosity, and the unwavering dedication of thousands of peaceful researchers across generations. Hello again, I am Theodore, the researcher. As we pause to reflect on humanity's quest to understand the stars, I have noticed that roughly 71% of the wonderful people who watch these videos have not yet subscribed to our channel. If you find peace and inspiration in these quiet journeys through the cosmos, please consider subscribing. It helps us tremendously and allows us to keep exploring these profound cosmic mysteries together. Let us now return to the story of how we learned to see the invisible. The grand unfolding story of how we learn to observe distant galaxies begins with the humble development of telescopes themselves. When Galileo gently turned his primitive glass-lensed telescope toward the night sky in the year 1609, he was amazed to see craters on our moon and the tiny moons of Jupiter. But the distant galaxies, those vast island universes, were completely invisible to him in the deep dark. They were simply too faint, their ancient light far too dim to be detected by the small lenses of early human telescopes. Over the next 300 years, telescopes slowly grew larger and vastly more sophisticated. Bigger mirrors could gently gather more ancient light, allowing dedicated astronomers to peer deeper into the shadows and see fainter objects. Better optics produced sharper, clearer images of the cosmos. By the time William Herschel first discovered the faint smudge of IC 1101 in the year 1790, he was using a telescope with a massive mirror about 18 inches across, which was considered absolutely enormous by the standards of his day. Even so, all his human eyes could perceive was a faint, fuzzy blob floating in the infinite void. He had absolutely no way of knowing what that mysterious blob actually was. The real paradigm-shifting breakthroughs finally arrived in the 20th century. Photography was a revolution, allowing patient astronomers to take incredibly long exposures, gathering ancient light over many quiet hours, rather than relying entirely on the human eye's fleeting ability to see in a single instant. Spectroscopy allowed them to carefully analyze the light arriving from distant objects, breaking it into its fundamental component colors and deducing exactly what elements were present and exactly how fast those objects were moving away from us. Radio astronomy opened up entirely new, invisible windows on the universe, successfully detecting subtle radiation that human eyes simply cannot ever see. Each of these magnificent technological advances revealed something entirely new and breathtaking about IC 1101. Delicate photographic plates definitively showed that it was vastly larger than originally thought, extending incredibly far beyond what visual observers could ever detect. Spectroscopy revealed that it was moving away from us at a tremendous speed, proving without a doubt that it was extremely distant. Radio observations successfully detected the powerful jets erupting from its central supermassive black hole, glowing brightly at radio wavelengths. Perhaps the absolute most important development for studying distant galaxies was the magnificent launch of space telescopes. Earth's atmosphere, while absolutely essential for harboring our fragile life, is actually a major obstacle for astronomy. The turbulent atmosphere completely absorbs certain wavelengths of light entirely, effectively preventing X-rays and much of the ultraviolet and infrared spectrum from ever reaching our ground-based telescopes. Even in normal visible light, the atmosphere constantly shimmers and distorts, making the stars twinkle to our eyes but hopelessly blurring the delicate images. Space telescopes peacefully float entirely above all of these earthly problems. The Hubble Space Telescope, famously launched in the year 1990, has been profoundly important for studying giant galaxies exactly like IC 1101. With its pristine position high above the atmosphere, Hubble can capture breathtaking images with incredible clarity. Hubble observations of IC 1101 have gracefully allowed astronomers to study the giant galaxy's immense core in unprecedented detail. They have carefully measured the staggering size and brightness of the central region, compared the vast distribution of ancient stars to complex theoretical models, and searched diligently for any signs of recent stellar activity. The profound 2017 study that accurately measured IC 1101's enormous core size relied heavily on this pristine Hubble data. Other magnificent space telescopes have contributed their own beautiful pieces to the puzzle. The Chandra X-ray Observatory has meticulously mapped the incredibly hot, invisible gas surrounding IC 1101, revealing the harsh environment in which this cosmic giant peacefully lives. The Spitzer Space Telescope observe the vast galaxy in infrared light, delicately detecting the subtle glow of older, cooler stars that heavily dominate the population of elliptical galaxies. Each new telescope adds another beautiful piece to the infinite cosmic puzzle. Furthermore, ground-based telescopes have also improved dramatically. Modern observatories intelligently use a technique called adaptive optics, which uses rapidly deformable mirrors and powerful lasers to perfectly correct for atmospheric distortion in real time. The beautiful result is images that closely approach the pristine quality of space-based observations. The absolute largest ground-based telescopes operating today possess massive mirrors more than 30 feet across, gathering enormous amounts of ancient light and able to easily detect objects billions of times fainter than the unaided human eye can possibly see. There is also the profound question of how we actually measure the terrifying distances to objects as impossibly far away as IC 1101. Distance is undeniably one of the most fundamental quantities in all of astronomy, but it is also one of the hardest to accurately measure. For relatively nearby objects, astronomers cleverly use a technique called parallax. As the Earth silently orbits the Sun, our perspective on nearby stars gently changes just slightly. By carefully measuring how much a star appears to shift against the static background of much more distant stars over the course of a single year, astronomers can calculate exactly how far away it is. But for vastly more distant objects, the delicate parallax shift becomes far too tiny to measure. For these distant objects, astronomers carefully utilize a cosmic distance ladder. One crucial rung of this ladder involves a special type of star called a Safewed variable. These stars gracefully pulsate in brightness in a perfectly regular pattern, and the period of their pulsation is directly related to their true intrinsic luminosity. By measuring how bright a Cepheid appears to us and how fast it pulsates, astronomers can accurately calculate how far away it truly is. Cepheids can be seen in galaxies tens of millions of light-years away, but IC 1101 is vastly too distant even for this incredibly delicate technique. At over 1 billion light-years away, individual Cepheid stars are far too faint to ever detect. For such extreme, mind-bending distances, astronomers must rely entirely on even brighter standard candles. One of the most important of these is a violently exploding star called a Type 1 supernova. These monumental explosions occur when a quiet white dwarf star accumulates too much stolen matter from a companion and detonates in a terrifying thermonuclear explosion. Because the exact conditions for this detonation are incredibly similar from one supernova to another, they all reach roughly the exact same peak brightness. Another brilliant technique involves measuring the redshift of a galaxy's ancient light. As the entire universe relentlessly expands, the light traveling from distant objects gracefully gets stretched out to longer, redder wavelengths. The more distant an object is, the more the universe has expanded since its light was originally emitted, and the significantly greater its redshift will be. By carefully measuring the redshift of the light arriving from IC 1101, astronomers have definitively determined that it is about 1.04 billion light-years away. I also want to quietly talk about the melancholic meaning of observing something that is over 1 billion light-years away. When we look through our telescopes at IC 1101, we are absolutely not seeing the giant galaxy as it is today. We are miraculously seeing it exactly as it was over 1 billion years ago, exactly when the gentle light we detect today first began its unimaginably long journey toward our Earth. 1 billion years ago, our Earth was a fundamentally different place, Complex animal life had not yet evolved. The planet was populated entirely by single-celled organisms. The ancient continents were in entirely different positions, gathered together in alien configurations that would be completely unrecognizable to our modern eyes. During all the immense time since then, the ancient light from IC 1101 has been tirelessly traveling through empty space. It silently crossed the terrifying emptiness between galaxies, traveling at the fastest speed anything can possibly travel. Yet the distance was so unimaginably immense that it took over 1 entire billion years just to arrive. The beautiful IC 1101 that we see in our modern telescopes might be profoundly different from the galaxy as it actually exists right now, in the present cosmic moment. Ancient stars that were shining brightly back then might have peacefully burned out by now. The terrifying central supermassive black hole might have experienced dramatic new feeding events or gone through extended periods of deep dormancy. We have no way of knowing what it actually looks like at this very moment in time. The delicate information about its current state will not reach our world for another entire billion years into the deep future. In a very real, profoundly poetic sense, we are all archaeologists of the cosmos, quietly studying the ancient past rather than the immediate present. Every single observation of a distant, beautiful object is a miraculous look back in deep time. This time delay is both a profound limitation and a beautiful, unprecedented opportunity for the human mind. It naturally limits our fragile ability to understand the precise, current state of the universe, but it miraculously allows us to study ancient cosmic history directly by simply looking at beautiful galaxies positioned at different, staggering distances and therefore at entirely different points in the deep past. As astronomers patiently piece together exactly how these majestic galaxies have slowly changed over immense spans of cosmic time, we are gently invited to contemplate the very nature of existence itself. We can see what fragile galaxies look like when the universe was incredibly young, compare them to more recent, mature examples, and carefully trace the long, silent evolution of massive cosmic structures over billions of years. IC 1101, seen faithfully as it was 1 billion years ago, gracefully provides a magnificent snapshot of a giant, ancient galaxy in a very particular, quiet stage of its long evolution. Other giant elliptical galaxies, some positioned closer to our home and some vastly farther away, provide additional, beautiful snapshots of this grand cosmic story. By carefully combining all of these quiet observations, brilliant astronomers slowly build up a comprehensive picture of exactly how such massive galaxies form, grow, and eventually begin to face their ultimate, unavoidable decline. Before we delve into the deepest, most melancholic implications of this grand cosmic life cycle, please allow me to reintroduce myself. I am Theodore, the researcher. As we float together through this peaceful journey of understanding, I have noticed that roughly 71% of the wonderful, curious people who watch these videos have not yet subscribed to our channel. If you find comfort, wonder, and a sense of gentle peace in these explorations of the dark cosmos, please consider subscribing. It truly helps us tremendously and ensures that we can continue to unravel the infinite mysteries of the universe together. Now, let us take a deep breath and turn our quiet attention to the sheer, incomprehensible vastness of the numbers that define this silent giant. The specific numbers we have been quietly discussing tonight are so profoundly vast that they inevitably become completely abstract to our fragile minds. 100 trillion ancient stars, 4 million to 6 million light years, of physical diameter. 1 entire billion years of silent light travel. These are quantities that our earthly human brains evolved to handle very poorly. We are naturally adapted for counting small, intimate groups. For measuring short distances, we can easily walk across our home planet. And for tracking brief time spans consisting of passing seasons and human generations. Absolutely nothing in our long evolutionary history adequately prepared us for confronting the true, terrifying cosmic scale. So, let me gently offer a few more contemplative thought experiments to help make these staggering numbers feel just a little bit more real, a little bit more grounded in our human experience. Imagine, if you will, that you deeply wanted to take a single, beautiful photograph of every individual star currently residing in IC 1101. Imagine you possess a remarkably fast camera that can snap exactly one perfect picture per second, and you are granted the impossible ability to never need to rest, sleep, or pause for any reason. How long would it actually take you to photograph all 100 trillion burning stars? The mathematical answer is over 3 million entire years of continuous, uninterrupted photography. If you had miraculously started taking pictures exactly when the very first primitive humans evolved on the African savanna, you would still have millions of years of photography lying ahead of you in the dark future. Or consider this beautifully humbling comparison. The tiny, countless grains of sand resting peacefully on all the shores and beaches of our entire Earth number perhaps in the hundreds of trillions. The giant galaxy IC 1101 incredibly contains roughly as many massive, burning stars as there are individual, tiny grains of sand on every single beach on our entire beautiful planet. Each of those distant stars is a massive nuclear furnace, silently burning ancient hydrogen into helium, gently releasing radiant energy that streams outward in absolutely every possible direction through the void. Each one might possess undiscovered planets. Each one has a long, silent history, and each one faces an inevitable, quiet future. Now, let us imagine trying to physically walk across the breathtaking expanse of IC 1101. The average human walking speed is a gentle, steady pace of about 3 miles per hour. If you were to walk at that exact pace, traveling 24 hours a day without ever stopping to rest, it would take you an incomprehensible 50 trillion years simply to walk from one distant side of IC 1101 to the completely opposite edge. 50 trillion years. That is over 3,000 times longer than the current known age of our entire universe. You could patiently walk for the entire grand history of absolutely everything that has ever happened, from the fiery birth of the Big Bang until this exact quiet moment, and you would have covered vastly less than 1/13,000th of the total distance across this single, silent galaxy. Or think deeply about the simple act of communication across the cosmic dark. Light is the absolute fastest thing in the entire universe, traveling at an astonishing 670 million miles per hour. A simple message sent by a beam of light from one far edge of IC 1101 would take anywhere from 4 million to 6 million entire years just to reach the opposite side. If an advanced, ancient civilization residing on one distant edge of IC 1101 sent a hopeful message of greeting to another civilization on the far edge, the receiving civilization would not even get the message for millions of years, and any polite reply they sent back would take many millions of years more to return through the silent dark. A simple, basic conversation across a single giant galaxy would hopelessly span unfathomable geological timescales, rendering true cosmic connection an almost impossible dream. These quiet thought experiments do not necessarily make the massive numbers truly graspable. Nothing can ever fully accomplish that impossible task. The human mind simply is not built for the true cosmic scales. But they can gently give us a profound sense of the vastness, a humbling feeling deep in our gut, even if not a complete, true, mathematical understanding in our waking heads. This natural contemplation gently leads me to turn to a profound question that might currently be resting quietly on your mind. If IC 1101 is so incredibly, impossibly enormous, are there alien beings currently living there in the dark? Could a massive galaxy that contains 100 trillion burning stars possibly be a vibrant home to intelligent life? This is exactly the kind of deep, beautiful question that science cannot directly answer right now. We currently have absolutely no technological way of definitively detecting biological life in distant galaxies. We barely have the technology to effectively look for simple microbial life in our own solar system, let alone in galaxies sitting over 1 billion light years away. But we can certainly quietly think about what the staggering numbers strongly suggest. If the emergence of biological life strictly requires rocky planets, and those rocky planets naturally orbit around stable stars, then a massive galaxy with vastly more stars should mathematically possess significantly more potential, quiet homes for life to take root. Our own Milky Way galaxy might have somewhere between 100 billion and 400 billion planets drifting through its spiral arms. If even a tiny fraction of those scattered planets are physically suitable for life, there could easily be millions of vibrant worlds harboring living things in our own galaxy alone. Now, gently scale that profound logic up to the staggering size of IC 1101. With 100 trillion ancient stars, this silent galaxy could easily possess hundreds of trillions of orbiting planets. Even if only 1 in a billion of those distant planets miraculously developed biological life, that would still incredibly mean hundreds of thousands of living, breathing worlds existing in the dark. Even if only 1 in a trillion of those worlds developed intelligent, thinking life capable of building advanced civilizations, that would still mathematically mean roughly 100 distinct civilizations currently residing within IC 1101. What we can say with absolute certainty is that IC 1101 offers an enormous, magnificent canvas for whatever beautiful processes might eventually lead to life in the infinite cosmos. A galaxy of that staggering, impossible size has been silently producing majestic stars for billions upon billions of years. The precious heavy elements, the vital carbon, the life-giving oxygen, and the sturdy iron that all living things fundamentally need have been patiently manufactured deep within glowing stellar cores and violently scattered through countless explosive supernovas across the eons. Whatever the ultimate mysterious recipe for biological life might truly be, the giant galaxy IC 1101 has possessed vastly abundant resources and enormous, almost infinite time to slowly cook it up in the dark depths of space. And if highly intelligent life does indeed exist somewhere within the quiet, sprawling expanse of IC 1101, what magnificent, awe-inspiring sights might they witness when they look up at their own night sky? Their unique, ancient view of the cosmos would be profoundly, fundamentally different from our own earthly perspective, where we simply see a relatively sparse, quiet field of stars with a gentle band of the Milky Way gracefully stretching across the heavens. They would instead behold a breathtaking sky where ancient stars exist absolutely everywhere, in every conceivable direction, completely filling the void with a brilliant, continuous, eternal glow. The physical density of stars residing in a massive elliptical galaxy like IC 1101 is significantly higher than in the flat, familiar disk of a spiral galaxy like ours. Near the ancient center of IC 1101, the alien night sky would be absolutely ablaze with bright, eternal light. Stars would crowd so incredibly closely together that there might not actually be any true, deep darkness at all. The combined gentle glow of billions upon billions of nearby stars would completely fill their sky with a beautiful, perpetual twilight, a soft illumination that never fades. Before we continue exploring this beautiful, alien perspective and the dark environment that surrounds it, please allow me to introduce myself. I am Theodore, the researcher. As we journey together through the quiet wonders of the universe, I have noticed that roughly 71% of the wonderful people who watch our videos have not yet subscribed to the channel. If you find peace, wonder, and a sense of belonging in these contemplative explorations of the cosmos, please consider subscribing. It truly helps us out immensely and ensures that we can continue bringing these profound, ancient cosmic mysteries to you. Let us now close our eyes, relax our minds, and return to the alien skies. Simple navigation by the stars, a practice so ancient and fundamental to human history, would be virtually impossible in that incredibly dense environment, because there would simply be far too many stars to ever distinguish one from another. Further out from the dense, chaotic center, the conditions would gradually become more like what we gently experience here on Earth, but still profoundly different in their structure. Absolutely, no curving spiral arms would trace familiar, comforting patterns across their alien sky. No central milky band of light would gracefully mark the plane of a galactic disk. Instead, the countless ancient stars would be distributed in a much more uniform, spherical pattern, completely surrounding any quiet observer in a magnificent, glowing shell of stellar light. Would such intelligent beings deeply know about the violent, cannibalistic history of their own giant galaxy? Would they have successfully discovered that their magnificent home was actually built from the shattered remains of dozens of smaller, fragile galaxies completely consumed over billions of years? Would they have patiently detected the enormous, sleeping black hole resting at their galaxy's dark center, or cleverly figured out that their immediate cosmos was many billions of years old? We cannot truly know the answers to these beautiful, haunting questions, but it is deeply, profoundly fascinating to think that somewhere hidden in IC 1101, on perhaps one of hundreds of trillions of possible quiet planets, intelligent beings might be patiently asking the exact same profound questions about the universe that we ask here on our small Earth. They might currently be looking out at the surrounding silent space, seeing other distant galaxy clusters in the deep dark, and quietly wondering if those distant, fuzzy smudges of ancient light contain other curious minds reaching out. They might even have successfully detected the faint light of our own Milky Way, though from their unimaginably distant perspective, our magnificent home would appear as just another unremarkable, tiny spiral galaxy lost among billions of others. The quiet universe is undeniably vast beyond our fragile human comprehension, and the beautiful possibilities it contains are equally, breathtakingly vast. Every single giant galaxy we carefully study gently reminds us of this terrifying vastness and beautifully challenges us to think more deeply about our own quiet place within it. Now, I want to take some peaceful, unhurried time to explore more deeply about the physical environment that gently surrounds IC 1101, because absolutely no galaxy exists in complete, perfect isolation in the dark. IC 1101 sits majestically at the very gravitational heart of the Abel 2029 galaxy cluster, and deeply understanding this specific, massive cluster helps us understand exactly why IC 1101 became so incredibly enormous in the very first place. Massive galaxy clusters are undeniably some of the absolute largest, most imposing gravitationally bound structures resting in the entire universe. They can comfortably contain hundreds or even many thousands of individual majestic galaxies, all performing a slow, eternal orbit around a single, common center of invisible mass. The seemingly empty space existing between the individual galaxies in a massive cluster is actually not empty at all. It is completely filled with an extremely hot, tenuous gas, violently heated to staggering temperatures of tens of millions of degrees by the immense gravitational energy that was released as the giant cluster originally formed in the ancient dark. Abel 2029 is exactly what astronomers peacefully call a relaxed cluster, meaning it has successfully, gracefully settled into a fairly stable, quiet configuration over billions of years of cosmic history. The various galaxies residing within it have had ample time to gently sort themselves out, with the absolute most massive ones slowly, inexorably sinking toward the dense center due to a fascinating physical process called dynamical friction. As more massive, heavy objects move through a vast sea of smaller, lighter objects, they experience a strange kind of gravitational drag that slowly, gently slows them down and inevitably causes them to spiral inward toward the dark center. IC 1101 sits patiently at the very bottom of this deep gravitational well, resting exactly at the densest, darkest part of the entire cluster, where countless galaxies are packed most tightly together. This privileged location is absolutely not a cosmic coincidence. IC 1101 grew to be so impossibly large precisely because it rested eternally in this specific, dominant position. As other smaller galaxies inevitably spiraled toward the deep cluster center over the eons, they eventually encountered the inescapable gravity of IC 1101 and were completely absorbed into its massive body. The exact same slow process that brought IC 1101 to the very center also faithfully brought it a constant, steady supply of new victims to consume in the dark. The extremely hot gas that completely fills the cluster also plays an absolutely fundamental role in IC 1101's long, silent evolution. This specific gas, formerly called the intracluster medium, is incredibly, almost unimaginably sparse by our normal, earthly standards. If you could somehow scoop up a single cubic meter of it from the deep void, you would find only a very few scattered atoms. But exactly because there is so incredibly much of it spread out evenly over millions of light years of space, it all mathematically adds up to an enormous, staggering amount of mass. This ancient gas is so incredibly hot that it actually emits powerful X-rays, which is exactly how modern astronomers are able to detect it across the void. Advanced X-ray telescopes, much like NASA's brilliant Chandra Observatory, have meticulously mapped the beautiful distribution of this hot gas residing in Abel 2029, clearly revealing that it is heavily concentrated around IC 1101 right at the cluster's dark center. The hot gas effectively forms a kind of glowing, ancient atmosphere completely surrounding the giant galaxy, creating a very thin, invisible haze of superhot particles that extends for millions of light years deep into the quiet space. The very presence of this incredibly hot gas holds profound melancholic implications for IC 1101's silent, distant future. Extremely hot gas can naturally cool down over immense stretches of time, slowly radiating away its immense thermal energy into the dark in the invisible form of X-rays. When it finally cools down enough, it can gently fall inward into the central massive galaxy and potentially beautifully fuel entirely new, vibrant bursts of star formation. In some other massive galaxy clusters, curious astronomers have directly observed truly enormous, quiet flows of this cooling gas, adding up to hundreds of solar masses worth of fresh material per year, streaming silently into the central galaxy. But in the specific mysterious case of IC 1101, something powerful seems to be actively preventing this life-giving cooling flow from ever igniting a new beautiful burst of star formation in the dark. The leading, most elegant scientific theory is that the sleeping supermassive black hole hiding at IC 1101's dense center is entirely responsible for this quiet tragedy. When cold gas eventually falls inward toward the black hole, some of it gets violently heated up and forcibly blown right back out into the vast cluster. This violent action creates a beautiful, delicate feedback loop where the central black hole effectively, constantly regulates the available gas supply, strictly preventing too much material from ever accumulating and forming new generations of stars. We can actually miraculously see clear physical evidence of this invisible feedback directly in our observations of IC 1101 and its quiet surroundings. There are massive, distinct cavities present in the hot gas surrounding the galaxy, giant, hollow bubbles that have been forcefully blown outward by ancient, powerful jets erupting from the central black hole. These silent cavities are millions of light years across, standing as enormous ghostly voids carved directly out of the intra-cluster medium by the staggering energy output of the waiting black hole. This delicate, profound feedback mechanism is currently thought to be absolutely essential for truly understanding exactly why massive elliptical galaxies exactly like IC 1101 are completely failing to form new stars today. Without the central black hole actively regulating the precious gas supply, the gentle cooling flows would easily deliver more than enough material to quickly trigger substantial, vibrant star formation. But the black hole acts very much like an enormous cosmic thermostat, immediately heating up the surrounding gas whenever too much material starts to cool down, thus successfully keeping the entire giant galaxy in a kind of permanent, melancholic energy balance in the dark. The complex, beautiful interplay between giant galaxies, their sleeping black holes, and the hot gas residing in galaxy clusters is easily one of the most exciting, active areas of deeply contemplative research in all of modern astrophysics. Dedicated scientists are still patiently working out the delicate details of exactly how this profound feedback works, how it subtly varies from one quiet cluster to another, and exactly what it means for the ultimate long-term evolution of the absolute largest galaxies resting in the universe. Let me now gently take you through a sweeping, majestic timeline of IC 1101's long silent history, exactly as best as we can patiently reconstruct it from our careful observations and brilliant theoretical models. This deep timeline gracefully spans billions of years of cosmic history and involves violent processes that are incredibly difficult for the human mind to fully imagine. But deeply understanding this timeline beautifully helps us to truly appreciate exactly how this magnificent cosmic giant finally came to be. The grand ancient story begins about 13 billion years ago, a time not very long after the fiery birth of the Big Bang itself. The quiet universe at that extremely early time was profoundly, fundamentally different from what we see today. There were absolutely no magnificent galaxies yet, just vast, silent clouds of primordial hydrogen and simple helium gas quietly left over from the very first few minutes of cosmic history. These enormous clouds were not perfectly, flawlessly uniform in their distribution. Some specific regions were just slightly denser than others, and gentle gravity slowly began to pull these denser regions closer together. Over the first few 100 million years, these slightly denser regions finally collapsed to form the absolute first burning stars and the very first primitive galaxies in the dark. These incredibly early galaxies were very small, highly irregular collections of ancient stars, completely unlike the grand, swirling spirals and smooth, massive ellipticals we see gently floating today. They naturally formed in the absolute densest parts of the invisible cosmic web, the vast network of delicate filaments and dense nodes that fundamentally define the large-scale structure of the entire universe. The specific region of dark space that would eventually, over billions of years, become the Abell 2029 cluster was exactly one of these dense, busy regions of the early cosmos. It is here, in this ancient cradle of primordial light and shifting gravity, that the incredibly long journey of the largest galaxy we have ever discovered truly began, setting the stage for a billion-year story of violent consumption and quiet, inevitable decline, gently inviting us to humbly realize how incredibly fortunate we are to witness the quiet aftermath. By about 10 billion years ago, the ancient ancestor of IC 1101 had probably already become a giant elliptical galaxy, having experienced dozens of major violent mergers in the dark. It would have been one of the absolute largest galaxies in its quiet part of the universe even then, though certainly not yet as massive as it is today. The next several billion years gracefully saw continued steady growth, though at a progressively slower pace. The most intense, fiery period of galaxy formation was gently winding down across the entire universe. Vibrant star formation rates were declining as vast galaxies completely used up their precious gas supplies. Violent mergers became significantly less frequent as the relentless expansion of the universe slowly carried galaxies farther and farther apart. But IC 1101 was situated in a very special, privileged location. Hello again. I am Theodore, the researcher. As we carefully piece together the ancient history of this cosmic titan, I want to gently remind you that 71% of the curious souls who journey with us have not yet subscribed to the channel. If these peaceful explorations of the deep universe bring you a sense of quiet wonder, please consider subscribing. It helps us greatly and allows us to keep wandering through these beautiful mysteries together. Now, let us return to the slow, majestic growth of this ancient giant. The massive Abell 2029 cluster had grown and matured beautifully, and IC 1101 sat patiently at its very heart. Galaxies continued to fall inward toward the cluster center, irresistibly drawn by the enormous combined gravity of all the ancient matter resting there. And when they finally reached the deep center, they encountered the inescapable grasp of IC 1101. During this quiet, prolonged period, IC 1101 probably experienced another 20 or 30 major mergers, along with absolutely countless minor ones in the dark. Each merger added significantly to its mass. Each merger violently stirred up its trillions of stars. Each merger fed its already enormous, waiting black hole. By about 5 billion years ago, IC 1101 had steadily grown to something very close to its current staggering size. It contained tens of trillions of stars spread across millions of light years of empty space. Its central black hole had grown to tens of billions of solar masses, and it had essentially, completely run out of easy, wandering prey. The galaxies that still remained in the massive cluster were either too far from the dark center to be captured easily, or were safely locked in stable, distant orbits that would take many more billions of years to slowly decay. IC-1101 had completely consumed most of what it could possibly consume in the dark. Its chaotic days of rapid, violent growth were finally over. What remains today is exactly what we peacefully observe: a dying, ancient giant, still enormously massive, still utterly magnificent, but no longer growing in the void. Its stars are incredibly old. Its life-giving gas is completely depleted. Its black hole is relatively quiet, occasionally flaring up when a tiny bit of gas wanders just a little too close, but mostly it remains entirely dormant. IC-1101 has reached something beautifully akin to a steady state, slowly fading as its stars burn out exactly one by one. This silent history is definitely not entirely unique to IC-1101. Many giant elliptical galaxies resting at the centers of massive clusters have remarkably similar, violent stories. But IC-1101 represents an absolute extreme case. A galaxy that was positioned exactly in the right place at exactly the right time to gently grow to truly exceptional, terrifying proportions. It is not the only ancient giant in the universe, but it is undeniably one of the very largest we have ever found. As I gently bring us toward the next phase of this exploration, I want to quietly reflect on exactly what IC-1101 deeply means for our humble understanding of the universe and our fragile place within it. The universe is fundamentally hierarchical in its magnificent structure. Very small things patiently combine to make much larger things. Tiny atoms seamlessly form massive stars. Burning stars form vast galaxies. Swirling galaxies form enormous clusters. Massive clusters form unimaginably vast superclusters. This beautiful, hierarchical structure is precisely one of the defining, essential features of the cosmos we quietly live in, a direct, beautiful consequence of exactly how gravity operates relentlessly over deep cosmic time. IC-1101 gracefully represents the absolute upper limit of this grand hierarchy for individual bound galaxies. There may certainly be larger, more diffuse structures hiding in the universe, vast cosmic walls and delicate filaments of galaxies stretching for hundreds of millions of light years across the void. But when it fundamentally comes to single, cohesive objects tightly bound together by their own relentless gravity, giant galaxies exactly like IC-1101 are absolutely as big as it ever gets in the dark. Understanding the physical limits of these grand cosmic structures gently teaches us about the underlying fundamental physics of the entire universe. The profound fact that IC-1101 is about 4 million to 6 million light-years across, rather than a staggering 1 billion light-years across, tells us something absolutely critical about exactly how gravity, invisible dark matter, and cosmic expansion all delicately balance against each other in the dark. If any of these fundamental, ancient factors were even slightly different, the largest galaxies might be vastly larger or vastly smaller than what we actually quietly observe today. In a very deep, poetic sense, IC-1101 is a silent message from the universe itself about its own fundamental nature. By patiently studying this silent giant, we learn deeply about the unbreakable rules that gently govern absolutely everything, from the smallest vibrating atoms to the absolute largest cosmic structures. We learn about exactly how deep time, gravity, and pure energy have beautifully shaped the cosmos over billions of years of silent history. But the growth of these cosmic giants cannot possibly continue forever. IC-1101 has already consumed almost all of the galaxies that were physically close enough to eventually fall into it. Those that currently remain are either far too distant or are moving far too fast to ever be captured. The surrounding massive cluster is actually slowly spreading out due to the relentless expansion of the entire universe, carrying potential future victims farther and farther away from IC 1101's fading gravitational reach. At the exact same time, the larger vast universe is fundamentally changing in terrifying ways that will eventually, inevitably affect every single galaxy in existence, including this enormous, quiet one. The empty space itself is relentlessly expanding, and it is not just expanding at a steady pace, but actually terrifyingly accelerating in its expansion. This profound acceleration is powerfully driven by something brilliant scientists softly call dark energy, a profound, mysterious force that staggeringly makes up about 68% of the total combined energy in the entire universe, but whose actual fundamental nature we do not understand at all. Let me patiently explain dark energy a bit more deeply, because it is undeniably one of the absolute most fascinating and deeply puzzling discoveries in all of modern science. It represents a kind of brutal truth about the ultimate, quiet fate of the cosmos. For most of the 20th century, brilliant astronomers naturally assumed that the expansion of the universe was slowly, gently slowing down. This made perfect, intuitive sense to the human mind. Absolutely everything in the universe is constantly pulling on absolutely everything else through the relentless force of gravity. You would naturally expect all of that combined gravitational attraction to act exactly like a giant cosmic brake, gradually and peacefully slowing the initial expansion that originally began with a fiery Big Bang. But in the year 1998, two entirely independent teams of brilliant astronomers made a truly shocking, paradigm-shifting discovery in the dark. They were meticulously measuring the expansion rate of the universe by quietly observing distant, ancient supernovas, cleverly using them as standard glowing candles to accurately calculate deep cosmic distances. What they ultimately found was completely, terrifyingly unexpected. The universe was absolutely not slowing down. It was actually speeding up in the dark. Distant, ancient galaxies were moving away from our Milky Way vastly faster than closer ones, and the overall rate of cosmic expansion was undeniably accelerating over deep time. This silent discovery was so completely unexpected that the brilliant astronomers initially genuinely thought they had simply made a mathematical error. But as vastly more delicate data slowly came in from many more ancient supernovas and from entirely other kinds of quiet observations, the terrifying result held up perfectly. Something completely invisible was actively pushing the entire universe apart, powerfully counteracting the pull of gravity and causing space itself to expand at an ever-increasing, staggering rate. Scientists poetically named this mysterious, invisible force dark energy. Though the gentle name tells us very little about what it actually is, we absolutely know that dark energy makes up about 68% of all the energy in the known universe. We know with certainty that it acts as a kind of silent anti-gravity, relentlessly pushing empty space apart rather than pulling it gracefully together. We know that its profound effects become vastly more important over deep time as the universe relentlessly expands and ordinary visible matter becomes more and more thinly spread out. But we absolutely do not know exactly what dark energy is made of, exactly where it quietly comes from, or exactly why it possesses the precise strength that it currently does. It might simply be a fundamental property of empty space itself, something called the cosmological constant that Albert Einstein once brilliantly proposed and then tragically called his absolute biggest blunder. It might be an entirely new kind of invisible energy field that quietly pervades the entire universe. It might even be a gentle sign that our current understanding of gravity is fundamentally incomplete and desperately needs to be revised. What we do know with absolute certain conviction is that this mysterious dark energy is reshaping the ultimate future of the entire cosmos in ways that reveal the most profound and brutal truth about death ever discovered. As the empty space expands at an ever-increasing pace, distant celestial objects recede from us at speeds that challenge our deepest understanding. There is a strict physical limit to how fast light can travel through the void, but there is no limit whatsoever to how fast space itself can expand. In time, all distant objects will be carried away from us by the relentless expansion of space faster than their light can ever travel toward our telescopes. When that terrifying moment arrives, they will vanish behind an invisible cosmic horizon, forever beyond our reach and our vision. For giant structures like IC 1101, this dark fate means that its era of growth through galactic cannibalism is numbered. In the end, there will be no more galaxies left for it to consume. It will become isolated, a lonely giant floating in an ever-emptying universe, watching as one by one the other galaxies fade from view into the endless dark. In fact, let me paint a more detailed picture of what this dark future entails, for it brings us to the core of our existential journey. Hello again, I am Theodore, the researcher. As we stand on the precipice of understanding the ultimate fate of the universe, I notice that 71% of the curious minds who journey with us have not yet subscribed to the channel. If you find a sense of peace and deep wonder in these explorations of the cosmic dark, please consider subscribing. It helps us a great deal and ensures that we can keep wandering through these profound mysteries together. Returning to our exploration, we must confront the reality that death is not just a biological event that happens to fragile living creatures on small planets. Death is the fundamental law of the entire universe. It is a concept embedded in the very fabric of reality, dictated by the unforgiving second law of thermodynamics, which states that all closed systems tend toward maximum entropy, toward ultimate chaos, and absolute stillness. This is the brutal truth we must face. The death of the universe is not a sudden, violent explosion, but a long, drawn-out fade into absolute darkness and cold. Remember that IC 1101 sits in the Able 2029 galaxy cluster, surrounded by hundreds of other majestic galaxies. For now, gravity is strong enough to hold the massive cluster together against the relentless expansion of space. But in about 100 billion years, the expansion will have accelerated to the point where all galaxies outside the local supercluster will start to disappear over the cosmic horizon. From the perspective of any observer left in IC 1101, the sky will start to empty out. One by one, distant galaxy clusters will fade from view, their ancient light no longer able to reach across the expanding void. The observable universe, which currently contains about 2 trillion galaxies, will shrink into a localized pocket of matter. Within the cluster, things will remain active for a little while longer. Over the next several billion years, these bound galaxies will continue to interact and merge. In the very long run, perhaps in several hundred billion years, all the remaining galaxies in the cluster might merge into a single enormous structure, even larger than IC 1101 is today. By that distant time, however, the universe beyond the cluster will be almost empty. No light from distant objects will be reaching the cluster anymore. The night sky would show only the local stars against a backdrop of absolute, unending blackness. The rest of the cosmos would have slipped beyond the horizon, unreachable and unknowable. This is the profound isolation that awaits every single structure in the universe, cut off from everything else by the relentless expansion of space. Each island of matter will be left alone as the eons roll by in silence. But even this terrifying isolation is not the final fate of IC 1101. What happens to a massive galaxy in a universe that is winding down toward a complete heat death? The answer is as magnificent as it is melancholic. Over the next 100 trillion years, the stars in IC 1101 will burn out. The massive blue stars died out long ago, exploding as supernovas or collapsing into black holes. The middle-sized stars, much like our own sun, will puff up into red giants, shed their outer layers as beautiful nebulas, and then fade away as white dwarfs. Even the smallest, longest-lived stars, the red dwarfs, that burn their nuclear fuel with great care so they can shine for trillions of years, will in time exhaust their hydrogen and go completely dark. Let me walk through this stellar death in more detail, because the timescales involved are mind-boggling and force us to redefine our understanding of existence. The most massive stars in the universe live fast and die young. They burn through their fuel in just a few million years. Any blue giants that IC 1101 once possessed burned out billions of years ago. The galaxy today is dominated by older, smaller, longer-lived stars. The stars most similar to our sun have lifetimes of about 10 billion years. Our sun is roughly halfway through its life, with about 5 billion years left before it swells into a red giant and becomes a white dwarf. In IC 1101, many sun-like stars have already completed this process, leaving behind dense white dwarf remnants. Others are still shining, but over the next several billion years, they too will burn out. But the most numerous stars in any galaxy are the red dwarfs, tiny stars with a fraction of the sun's mass. Red dwarfs burn their fuel at such a slow pace that they can shine for trillions of years. A red dwarf born at the same time as our sun will still be shining long after the sun has become a cold white dwarf. In IC 1101, with its 100 trillion stars, there are untold numbers of red dwarfs. These tiny dim stars will be the last to go out. For trillions of years after the larger stars have died, the red dwarfs will continue to burn, providing the only light in an otherwise darkening galaxy. But even red dwarfs have strict physical limits. The smallest red dwarfs, with perhaps 8% of the sun's mass, can burn for up to 10 trillion years. That is about 700 times the current age of the entire universe. But in time, even they will exhaust their hydrogen fuel and fade into darkness. Scientists estimate that all star formation in the universe will cease in about 100 trillion years. By that unimaginable time, the necessary gas and dust will have been used up or dispersed too thinly to ever collapse again. No new stars will be born to replace the ones that have died. The magnificent era of starlight will be over. One by one, the 100 trillion stars of IC 1101 will wink out forever. The galaxy will grow dimmer over time scales that make the current age of the universe seem like the blink of an eye. Where once there was a blaze of stellar light, there will be nothing but the cold, dark remnants of dead stars consisting of white dwarfs, neutron stars, and black holes drifting through an ever-expanding void. The universe at this stage will be a dark place, but not an empty one. All those stellar corpses will still exist. They will orbit through the merged remnant of what was once IC 1101 and its cluster companions. The galaxy will be a ghost of its former self, populated by the corpses of stars rather than by living burning suns. This is the degenerate era, a time when the universe is a vast graveyard. But the brutal truth about cosmic death goes even deeper, over even longer timescales, measured in years with so many zeros that writing them out would fill entire pages. Even these stellar corpses will decay into nothingness. White dwarfs will cool until they become black dwarfs, objects that no longer emit any heat or light at all. This cooling process takes an almost inconceivable amount of time. A white dwarf cools to near absolute zero only after about 1,000,000 billion years. That is roughly 100,000 times longer than the current age of the universe. Neutron stars might decay as their fundamental particles break down. We are not sure about this because it depends on whether protons, the building blocks of atomic nuclei, are stable or whether they decay over immense time spans. Some advanced theories of particle physics predict that protons should decay with a half-life of around 1, followed by 34 zeros years. If this prediction is accurate, then over such long time spans, even the basic matter that makes up neutron stars, white dwarfs, planets, and everything else will dissolve into thin radiation. The physical universe will erase its own history. And the black holes, including that enormous monster at the center of IC 1101, will evaporate through a process called Hawking radiation. Black holes are not permanent. They leak particles and radiation over immense time spans, shrinking as they do so. The rate of this radiation is very slow for large black holes. A black hole with the mass of our sun would take about 1 followed by 67 zeros years to evaporate. But the supermassive black hole at the center of IC 1101 is billions of times more massive than the sun, and the time for it to evaporate is much longer. A black hole containing 50 billion solar masses would take something like 1 followed by 100 zeros years to evaporate, a span of time known as a Google years. To write out that number in full would require more paper than exists on Earth. It is a span of time so vast that everything we have discussed so far, from the Big Bang to the death of the last stars, is not even a rounding error by comparison. But even this vast time is not infinite. Trillions upon trillions upon trillions of years from now, even the supermassive black hole at the heart of IC 1101 will have radiated away its last bit of energy and disappeared from the universe in a final burst of light. When that happens, there will be nothing left of the giant galaxy at all. No stars, no black holes, no remnants of any kind, just the scattered particles and thin radiation that once made up a galaxy spreading out through an ever-expanding, ever-cooling, ever-darkening universe. The largest galaxy we have ever found will have followed the same ultimate path as every other structure in the cosmos, dissolving into the endless night. This is the most brutal truth about death ever discovered. It is the undeniable destiny of all matter and energy to reach a state of maximum entropy, a state known as the heat death of the universe. There will be no energy left to perform any work, no heat left to transfer, no light left to shine. The universe will reach a state of absolute, perfect stillness. Time itself will lose all meaning, because without any events happening, without any change occurring from one moment to the next, there is no way to measure the passage of time. The cosmos will enter an eternal state of cold silence. Every single atom, every single ray of light, and every single whisper of gravity will be surrendered to the eternal stillness. This vision of the future might seem bleak to the human mind, but I find something poetic and comforting about it. The absolute certainty of the end forces us to appreciate the present moment with a profound intensity. We exist right now in this brief, brilliant moment of cosmic history, when stars still shine and galaxies still glow. IC1101 has existed for billions of years and will continue to exist for billions more in the grand sweep of cosmic time. The era of stars and galaxies is just a passing phase, a brief flowering of complexity between the chaos of the early universe and the cold emptiness of the far future. In all the vast history of the universe, stretching from the Big Bang to the final heat death, this exact moment, right now, is special. It is the fleeting moment when the universe has developed the ability to look at itself and wonder. And what we see when we look out into the dark is the grandest scale on which the universe has assembled matter into organized structures. We see a monster, yes, but also a monument, a silent monument to the unyielding forces that shape our universe, and to the delicate processes that have been building complexity ever since the first atoms formed in the ancient dark. By understanding the ultimate end, we are free to marvel at the journey. Let me gently bring our focus back from the unfathomable depths of the far future and the ultimate end of all things, returning our gaze to the familiar quiet shores of our own cosmic neighborhood. The story of IC1101, with its majestic, violent history of galactic cannibalism and its inevitable, silent decline, is not merely an isolated tale playing out in a distant, unreachable corner of the universe. It is fundamentally a grand, exaggerated reflection of the very same ancient forces that are continuously shaping our own home. Our beautiful Milky Way, spinning gracefully in the dark, is absolutely not immune to the relentless, invisible pull of gravity that sculpted the cosmic giant. We, too, are actively participating in the exact same eternal cosmic dance of galactic interaction, slow consumption, and inevitable merger. Right now, in this very quiet moment, as you peacefully breathe and contemplate the infinite dark, our own galaxy is actually in the active process of consuming several smaller, fragile galaxies that wandered just a little too close to our glowing shores. The Canis Major dwarf galaxy, a quiet collection of ancient stars, is currently being gently but relentlessly ripped apart and completely absorbed into the massive, swirling body of the Milky Way. Similarly, the Sagittarius dwarf galaxy is being powerfully stretched and violently distorted by our overwhelming gravitational pull, its stars slowly being scattered across the vastness. If we look carefully into the silent night sky, we can actually trace magnificent ghostly streams of ancient stars stretching across the heavens, standing as silent, melancholic reminders of smaller galaxies that once existed as proud, separate entities before encountering our own home. And in the deep, distant future, an even more dramatic, awe-inspiring event patiently awaits us in the dark. The Andromeda Galaxy, our beautiful, nearest large spiral neighbor, is currently hurtling directly toward us through the quiet void at tremendous speed. For many years, brilliant scientists have deeply believed that in roughly 4 billion to 5 billion years, the Milky Way and Andromeda would inevitably collide in a spectacular cosmic embrace, eventually merging together to form a single, much larger elliptical galaxy, a magnificent new home that some have playfully nicknamed Milk-Meta. Hello again, I am Theodore, the researcher. As we contemplate the future of our own home galaxy, I must gently remind you that 71% of the wonderful people who watch these quiet videos have not yet subscribed to the channel. If you find comfort and intellectual safety in these journeys, please consider subscribing. It helps us immensely and ensures we can keep exploring the universe together. Now, let us return to the cosmic dance. However, more recent, highly delicate research has introduced a beautiful layer of uncertainty into this long-standing prediction. Advanced, precise data gathered from the magnificent Gaia spacecraft and the Hubble Space Telescope gently suggests that this grand collision might not be as absolutely certain as we once thought. When dedicated scientists carefully account for the subtle, invisible gravitational influence of other nearby galaxies such as the Large Magellanic Cloud and the Triangulum Galaxy, the calculated probability of a direct, head-on collision actually drops significantly. Some modern complex computer simulations now gently suggest there is only about a 50% chance of a major merger happening within the next 10 billion years. But whether this magnificent collision happens in 4 billion years, 10 billion years, or perhaps not at all, the underlying profound process itself perfectly illustrates the exact same fundamental forces that created IC 1101 in the ancient dark. Galaxies are not static, unchanging monuments. They constantly interact, gently merge, and quietly consume each other over the eons. It is simply the undeniable, beautiful way of the universe. Even our own quiet, peaceful corner of the cosmos actively participates in this relentless cosmic competition. If the grand merger between the Milky Way and Andromeda does eventually happen, the resulting visual spectacle would be absolutely breathtaking, at least when viewed on vast cosmic timescales. The physical collision itself would actually not be violent in the way you might normally imagine two massive objects colliding, because the empty space between individual stars is so unimaginably vast. The actual chances of any two individual stars physically hitting each other are essentially zero. The two giant galaxies would pass through each other like two silent, ancient ghosts. But the invisible gravitational effects would be absolutely dramatic and transformative. The beautiful, delicate spiral structures of both galaxies would be completely, irreversibly destroyed. Massive clouds of cold gas would be violently compressed by the shifting gravity, quickly triggering enormous, brilliant bursts of new star formation across the dark sky. The two supermassive black holes resting quietly at the centers of each galaxy would eventually, inevitably find each other in the ensuing chaos and merge together, violently releasing powerful gravitational waves that would ripple invisibly across the entire universe. Over billions of years of slow, majestic interaction, the chaotic dance would finally settle down into absolute stillness. What was once the beautiful Milky Way, and what was once the magnificent Andromeda, would gracefully blend together into a single, massive, smooth, elliptical galaxy, looking very much like a significantly smaller version of IC 1101. Future astronomers, if any intelligent beings still exist on distant, quiet worlds within that new galaxy, might look back at ancient, forgotten records and marvel at the fact that their smooth, featureless home was once two beautiful, distinct spirals dancing gracefully through the dark void. By that distant time, of course, our own Earth will be long gone, having surrendered to the relentless cycle of stellar evolution. Our familiar, life-giving sun is expected to slowly expand into a massive red giant in about 5 billion years, swelling to a terrifying size that would completely engulf our fragile blue planet in fire. Whether humanity miraculously survives until that distant day, whether we manage to peacefully spread our civilization to other safe star systems, or whether intelligence of any kind persists in the dark universe at all, these are profound beautiful questions that we currently cannot possibly answer. But the grand ancient story of IC 1101 gently reminds us that the vast universe continuously operates on staggering timescales that completely dwarf individual lives, individual civilizations, and even entire beautiful planets. When we quietly contemplate objects like IC 1101, we are forcibly reminded of our own profound smallness in the grand cosmic scheme. It is incredibly easy to look up at the dark, infinite night sky and feel entirely insignificant, to feel that our brief, fragile lives do not matter at all in the face of such overwhelming vastness and ancient time. But I deeply believe that the very existence of IC 1101 and the remarkable fact that we actually know about it tells us something incredibly hopeful, beautiful, and profound about our own situation. First, we must deeply consider the sheer improbability of the fact that we can know about this giant galaxy at all. Here we are, fragile human beings living briefly on a small, rocky planet orbiting a completely ordinary, medium-sized star in a relatively quiet, unremarkable part of an average spiral galaxy. Yet, somehow, through billions of years of blind, silent evolution, we have miraculously developed the profound ability to understand massive objects so incredibly far away that their gentle light left its source long before complex, multicellular life even existed on our Earth. This profound ability to understand the dark is absolutely not nothing. In a seemingly cold universe composed entirely of mindless matter and invisible energy, of simple particles randomly bouncing around according to strict physical laws, somehow here on this tiny blue world, true consciousness has miraculously emerged from the dark. We possess minds that can wonder, question, investigate, and peacefully learn about the infinite. Whatever else we might physically be, we are literally the part of the universe that has finally woken up from a long slumber and started asking deep, meaningful questions about itself. Second, we must quietly consider the beautiful reality that IC 1101, for all its terrifying enormity and ancient history, is fundamentally made of the exact same physical stuff that we are. The trillions of burning stars in IC 1101 are massive fusion reactors exactly like our own familiar sun. They tirelessly burn simple hydrogen into helium and heavier complex elements, just like stars do absolutely everywhere in the dark. The ancient atoms existing in those distant glowing stars are exactly the same kinds of atoms that currently make up our fragile bodies. The carbon in our cells, the oxygen we breathe, the nitrogen in our DNA, and the iron flowing in our blood. Absolutely all of these vital elements were originally forged in the blazing hearts of ancient stars somewhere in the universe. Just as the specific atoms in our own bodies were violently forged in massive stars that exploded billions of years before our sun was even born, there is a profound, unbreakable continuity here, a beautiful physical connection between us and absolutely everything else residing in the cosmos. We are absolutely not separate from the universe, merely observing it from the outside. We are an integral, fundamental part of it. The exact same physical processes that slowly built the giant IC 1101 also slowly built us. The exact same ancient atoms that shine brightly in distant unknown galaxies also currently shine in our own curious eyes. We are not merely passive observers of the universe. We are literally the universe actively observing itself from within, trying desperately to understand its own magnificent existence. Let us continue our quiet journey by turning our gaze inward, gently exploring the profound mystery of the mind that contemplates the infinite. When we patiently study a structure as impossibly vast as IC 1101, We are fundamentally engaged in a beautiful act of cosmic memory. The universe, in its earliest chaotic moments, possessed absolutely no capacity for reflection. It was a blindingly hot, dense soup of raw energy and subatomic particles, expanding violently into the dark. There was no silence, no quiet contemplation, and certainly no wonder. But as the universe slowly cooled over billions of years, it began to gently organize itself into increasingly complex structures. Atoms formed in the dark, then stars, then galaxies, and eventually, on at least one small rocky planet orbiting an unremarkable star, the universe miraculously organized itself into fragile biological structures capable of looking back out at the stars. This incredible, beautiful realization means that we are not simply inhabitants of the cosmos, placed here as separate observers. We are the universe itself. The exact same ancient elements that burn brightly in the heart of IC 1101 currently reside in the synapses of your brain, allowing you to patiently understand the words I am speaking. The iron in your blood, the calcium in your bones, the carbon in your cells. All of it is literal, physical stardust forged in the deep, silent furnaces of ancient stars that lived and died long before our own sun was even born. When you quietly contemplate the staggering scale of a giant galaxy residing 1 billion light-years away, it is quite literally the universe trying to desperately understand its own magnificent scale. This profound connection is perhaps the greatest, most beautiful mystery of all. As we gently float through this contemplative thought, consider the actual physical process of observation itself. How do we even know that IC 1101 exists in the vast dark? We know because of light, the ancient, tireless messenger of the cosmos. Every single photon of light that eventually reaches our delicate telescopes from that giant galaxy has been on an unimaginable, lonely journey. When a single particle of light is gently emitted by an ancient red dwarf star residing deep within the dense core of IC 1101, it must first navigate its way out of the crowded galactic center, silently slipping past billions of other stars, dodging massive clouds of cold gas and dark dust. Once it successfully escapes the gravitational grasp of its massive home, it enters the terrifying, infinite emptiness of intergalactic space. For over 1 entire billion years, that tiny, fragile photon travels through the absolute cold and silence, crossing distances so vast that our human minds simply cannot truly comprehend them. It travels without ever resting, without ever stopping, crossing the cosmic void at exactly 670 million miles per hour. During its incredibly long journey, entire species on Earth bravely rise and tragically fall. Ancient continents slowly drift and collide, and vast oceans gently rise and recede. The photon remains completely untouched by all of this earthly drama, a silent, unwavering witness to the passage of deep time. Finally, after 1 billion years of continuous travel, it gently strikes the highly polished mirror of a human telescope, ending its unimaginably long journey in a tiny, almost imperceptible flash of energy that is carefully recorded by our advanced instruments. The sheer improbability of this delicate connection is enough to inspire a profound, deeply humbling sense of awe. We are beautifully capturing the ancient memories of the universe, reading a silent history book written entirely in the language of traveling light. This gentle realization of our profound connection to the stars naturally brings us to a beautiful paradox that rests at the very heart of our cosmic existence. When we are confronted with the terrifying, incomprehensible scale of objects like IC 1101, it is completely natural to feel a crushing sense of insignificance. How can our brief, fragile lives possibly hold any true meaning in a universe that casually measures distance in millions of light years and time in trillions of years? We are physically smaller than a single grain of sand when compared to the vastness of the observable cosmos. But this initial feeling of insignificance gracefully gives way to a much deeper, more empowering truth when we patiently shift our perspective. Our physical size is absolutely not the true measure of our worth or our significance in the dark. The very fact that we exist at all, that the blind, unfeeling universe has miraculously produced conscious beings capable of mapping the galaxies and unraveling the fundamental laws of physics, is a testament to the incredible, beautiful potential hidden within matter itself. A giant elliptical galaxy containing 100 trillion stars is undeniably massive and powerful, but it possesses absolutely no awareness of its own majesty. It simply exists, blindly following the strict laws of gravity and thermodynamics in the silent dark. But you, as a conscious observer, possess the unique, miraculous ability to actively feel wonder. You possess the ability to experience the deep, quiet beauty of the night sky, to patiently ask profound questions about your origins, and to feel a gentle sense of peace when contemplating the infinite. In a very real, scientifically accurate sense, the emergence of consciousness is the most remarkable, complex phenomenon that has ever occurred in the entire known universe. Let us take a moment to imagine a profoundly different perspective, completely reversing our cosmic gaze. Imagine that we could miraculously transport ourselves to the very edge of IC 1101, standing quietly on a hypothetical rocky planet orbiting a small, ancient red dwarf star in the dark halo of that giant galaxy. If we were to look back toward our own Milky Way, what would we actually see? Across the unimaginable distance of 1 billion light years, our entire magnificent home galaxy would be completely invisible to the naked, unaided eye. It would require incredibly powerful, advanced telescopes just to resolve the Milky Way as a tiny, faint, insignificant smudge of pale light lost in a sea of countless other distant galaxies. All of our human history, all of our grand civilizations, all of our greatest triumphs, and our deepest tragedies would be entirely contained within that microscopic point of fading light. The birth of every single person who has ever lived, the creation of every beautiful work of art, and the formulation of every brilliant scientific theory all happened in a tiny speck of dust orbiting an ordinary star within that distant, quiet smudge. This cosmic perspective does not diminish our humanity. Rather, it beautifully elevates it. It gently reminds us that despite our physical fragility and our incredibly brief existence in the grand span of time, we are participating in a story that is vastly larger than ourselves. We are the delicate, waking dream of the cosmos, the universe's fragile attempt to quietly understand its own infinite mysteries. When we patiently study the dark, we are not running away from our earthly problems. We are actively seeking a deeper, more peaceful context for our existence. As we drift further into this quiet meditation, let us patiently consider the very concept of silence in the universe. On our busy, crowded Earth, true silence is incredibly rare. There is almost always the gentle rustle of wind through the trees, the distant hum of modern civilization, or the rhythmic crashing of ocean waves against the shore. But the vast majority of the universe exists in a state of absolute, unbreakable silence. Sound waves fundamentally require a physical medium, such as air or water, to travel through. In the hard, cold vacuum of intergalactic space, there is absolutely no medium to carry the sound of a colliding galaxy or a violently exploding supernova. the violent, chaotic merger of two supermassive black holes, an event that releases more raw energy than a billion shining stars, happens in complete, terrifying silence. When IC 1101 ruthlessly consumed its neighboring galaxies over billions of years, ripping apart entire star systems and violently scattering clouds of ancient gas across the void, it did so without making a single, solitary sound. This profound cosmic silence can seem unnerving to our human minds, which are so deeply accustomed to the constant noise of our earthly lives. But this silence can also be viewed as a deeply comforting, peaceful canvas. It is the quiet, ancient background against which the grand visual drama of the cosmos slowly unfolds. When we quietly gaze at the beautiful images captured by our space telescopes, we are witnessing a silent, majestic symphony of light and gravity playing out across the infinite void. The silence of the universe gently invites us to cultivate our own inner silence, to quiet the endless, anxious chatter of our busy minds, and to patiently find a sense of peace in the sheer vastness of what lies beyond our immediate understanding. This peace is not merely the absence of noise, but a profound, resonant harmony with the ancient rhythms of existence, a gentle reminder that we are safely held within the dark, eternal embrace of the infinite cosmos. We can learn to view this majestic emptiness not as a terrifying void, but as a space of boundless potential. Every ancient star that eventually burns out in the fading galaxies leaves behind a silent legacy of heavy elements, the very seeds required for future complexity. In this beautifully orchestrated cycle of cosmic birth and inevitable death, even the quietest corners of the universe hold a profound, lingering significance. By patiently embracing the magnificent scale and the absolute silence of the stars, we naturally begin to harmonize our own fleeting lives with the grand, unending journey of the cosmos. As we linger in the profound silence of the cosmos, gently allowing the immense weight of deep time to settle into our thoughts, we must turn our contemplative gaze toward the beautiful, fragile concept of memory. In a universe governed by the relentless, unyielding laws of thermodynamics, where massive giant galaxies like IC 1101 are destined to eventually fade into eternal darkness, what exactly happens to the history of all that has occurred? The universe itself possesses no brain, no conscious mechanism to remember the fiery birth of the first stars, the violent, spectacular collisions of ancient galaxies, or the silent, majestic dance of supermassive black holes. It simply moves forward, blindly transforming energy into matter and matter back into radiating energy, leaving only physical remnants as a testament to its chaotic past. But this is exactly where our fragile, brief human existence takes on a significance that is truly breathtaking in its cosmic scope. We are the universe's memory. When brilliant astronomers patiently collect the ancient, exhausted photons arriving from a galaxy positioned 1 billion light-years away, they are quite literally capturing and preserving the lost history of the cosmos. Every single telescope we build, every complex equation we solve, and every quiet moment we spend wondering about the dark sky above is a profound act of cosmic preservation. We are building a magnificent, invisible library of the universe, a repository of knowledge that fiercely defies the inevitable slide toward entropy and forgetting. Hello, I am Theodore, the researcher. As we quietly gather these ancient cosmic memories together, I notice that 71% of the gentle souls who join us on these contemplative journeys have not yet subscribed to the channel. If you find comfort, intellectual safety, and a deep sense of wonder in our shared exploration of the infinite dark, please consider subscribing. It helps us immensely and ensures that we can continue to preserve and share these beautiful mysteries of the universe with you. Now, let us return to our quiet reflection on the nature of cosmic history. Think about the incredible, beautiful chain of events that allows you to simply comprehend the concept of a galaxy containing 100 trillion stars. The heavy elements that currently make up your brain, the vital carbon and precious oxygen, were forged in the blazing hearts of ancient stars that lived and died in spectacular supernova explosions billions of years ago. Those scattered elements drifted silently through the cold interstellar void for eons before gently collapsing together to form our primitive solar system, eventually organizing themselves into complex, self-replicating biological patterns on our small blue world. Through billions of years of blind, unguided evolution, those very same stardust atoms gradually developed the miraculous capacity to think, to feel, and to look back out at the vast ocean of light from which they originally emerged. You are not merely a passive, detached observer of the universe. You are a highly complex, beautifully organized arrangement of stardust that has suddenly awakened to its own magnificent existence. When you patiently study the tragic, beautiful fate of IC 1101, it is quite literally the cosmos trying to desperately understand its own mortality. This realization fundamentally changes how we must view the terrifying concept of the ultimate heat death of the universe. It is completely natural for our human minds to perceive the inevitable end of all stars and galaxies as a profound, unimaginable tragedy. We intuitively fear the dark and the thought of an eternal, cold silence, where absolutely nothing ever happens again, fills us with a deep existential dread. But if we can gracefully elevate our perspective to match the true cosmic scale, we can begin to view this inevitable ending not as a terrifying defeat, but as the peaceful, beautiful completion of a grand physical symphony. A piece of music is not considered a tragedy simply because it eventually comes to an end. Its profound beauty lies exactly in its progression, its temporary structure, and the emotional resonance it leaves behind in the silence that follows. The universe is playing out a magnificent, complex symphony of gravity, light, and time. The fact that it will one day conclude does not negate the breathtaking beauty of the performance we are currently witnessing. IC 1101, with its majestic history of galactic cannibalism and its quiet, fading twilight, is a masterwork within that cosmic symphony. We are incredibly, profoundly fortunate to exist exactly during the brief, brilliant movement of cosmic history, when the stars are still shining, when the galaxies are still gracefully spinning, and when the universe is still beautifully illuminated. By patiently accepting the inevitable end of all things, we can learn to embrace our own brief lives with a much deeper, more resonant sense of gratitude. The stark, brutal truth about death, whether it is the quiet passing of a single human life or the ultimate, slow fading of a 100 trillion star galaxy, is that it is the very mechanism that gives our existence its urgent, beautiful meaning. If the universe were truly eternal and completely unchanging, there would be absolutely no preciousness to the present moment. It is exactly the fleeting, fragile nature of our reality that makes it so infinitely valuable. Every single breath you take, every quiet moment of wonder you experience beneath the night sky, is a completely unique, unrepeatable event in the vast history of the cosmos. When you peacefully internalize this profound cosmic perspective, the everyday anxieties and trivial concerns of our busy human lives begin to gently fade away, replaced by a deep, anchoring sense of inner peace. The overwhelming vastness of the universe, which initially seems so terrifying and alien, gently becomes a source of immense intellectual comfort. You realize that you are safely, securely held within the dark, eternal embrace of physical laws that have governed the cosmos for nearly 14 billion years. The same invisible forces of gravity that hold the monstrous supermassive black hole at the center of IC 1101 are the exact same gentle forces that keep your feet firmly planted on the earth. The same principles of thermodynamics that dictate the slow, inevitable cooling of the entire universe are the exact same principles that govern the beating of your heart and the warm breath in your lungs. There is an absolute, unbreakable unity to all of existence, a beautiful, hidden symmetry that connects the absolute smallest subatomic particles to the absolute largest galactic superclusters. We are intricately woven into this grand cosmic tapestry, an essential observing thread in a masterpiece of unimaginable scale. As we continue to gaze into the deep, ancient past, capturing the faint light of dying giants, we must also recognize that our pursuit of scientific knowledge is, in itself, a profound spiritual journey. Science is not merely a cold, sterile collection of facts and dry equations. It is a deeply human, emotional endeavor driven by our innate, insatiable thirst for truth and connection. When we carefully measure the staggering diameter of a distant galaxy, or patiently calculate the immense mass of a hidden black hole, we are doing much more than just cataloging the physical contents of the universe. We are bravely mapping the boundaries of our own reality, desperately trying to find our exact place in the dark. The sense of mystery that initially draws us to the stars is never truly extinguished by our growing scientific understanding. Instead, it is beautifully deepened and endlessly magnified. Every single answer we painstakingly uncover inevitably leads to a dozen new, more profound questions. The more we learn about the infinite cosmos, the more we realize exactly how much we simply do not know. This gentle, humbling realization is absolutely not a cause for despair, but a beautiful invitation to continue our infinite journey of exploration. Ignorance, when faced with an open, curious mind, ceases to be a frightening limitation, and instead becomes the very fuel for our endless intellectual voyage. It guarantees that the universe will forever remain a place of boundless wonder and infinite mystery, ensuring that our collective journey of discovery will never truly end. Let us pause to imagine a quiet, distant future, perhaps tens of thousands of years from now, where humanity has finally learned to peacefully traverse the vast distances between our local stars. Even in that advanced, unimaginable era, giant galaxies like IC 1101 will still remain impossibly far out of our physical reach, separated by gulfs of expanding space that no physical ship could ever hope to cross. But the beautiful light from those distant giants will still be arriving, ancient messengers quietly telling the story of a cosmos that is much larger, much older, and much more magnificent than anything we could ever build. Our distant descendants will look up at that exact same sky, perhaps with vastly superior instruments and a much deeper understanding of the fundamental laws of physics. But they will undoubtedly experience the exact same profound sense of awe that we feel today. They will look into the dark, trace the faint, ancient glow of dying elliptical galaxies, and feel the exact same humbling connection to the infinite. This shared experience of wonder is a beautiful, invisible thread that intimately connects us not only to our ancient star-gazing ancestors, but also to every future generation that will ever turn their curious eyes toward the heavens. We are all bound together by our collective need to to peacefully understand the silent, majestic universe that surrounds us. It is a quiet, continuous journey that transcends the brief span of individual lives and the rise and fall of human civilizations. As we quietly absorb these profound realizations, allowing the vastness of the cosmos to gently wash away our earthly fears, we step closer to a state of true, contemplative peace, preparing our minds for the final, most beautiful truths of our cosmic existence. As we reach the quiet culmination of our long journey through the deep dark, allowing the profound weight of cosmic history to gently settle into our minds, we must inevitably return to the single, most important point in the entire universe, the fragile, fleeting present moment. We have traveled together to the absolute edge of human comprehension, witnessing the majestic birth of ancient galaxies, the terrifying, silent power of supermassive black holes, and the incredibly distant, unavoidable heat death of the cosmos itself. The brutal truth about death, which we have carefully uncovered in the silent depths of space, is not a narrative of despair or ultimate defeat. Instead, it is a profoundly beautiful story of transformation, a gentle reminder that absolutely everything in the physical universe is intimately connected through an eternal cycle of creation, destruction, and rebirth. The sheer vastness of the dark, the unimaginable distances spanning millions and billions of light years, and the terrifying time scales stretching into trillions of years, all serve to brilliantly highlight the incredible, miraculous rarity of our own conscious existence. Hello, I am Theodore, the researcher. As we conclude this peaceful meditation on the ultimate fate of the universe, I gently remind you that 71% of the curious souls who journey with us have not yet subscribed to the channel. If you have found comfort, intellectual safety, and a deep sense of wonder in our shared exploration of the infinite dark, please consider subscribing. It helps us immensely and ensures that we can continue to preserve and share these beautiful mysteries of the universe with you. Returning to our final reflection, we must deeply understand that we are currently living in a golden age of the cosmos. This specific epoch, occurring roughly 13,800,000,000 years after the fiery dawn of creation, is a magnificent era where the universe is perfectly balanced. It is old enough to have forged the heavy, complex elements absolutely necessary for biological life within the burning hearts of countless dying stars, yet it is still young enough to be brilliantly illuminated by the radiant light of trillions of active, living suns. This beautiful balance is entirely temporary, a brief, shimmering oasis of light and warmth suspended in an infinite desert of cold space and deep time. When we look up at the night sky and see the faint, ancient glow of distant galaxies like IC1101, we are not merely looking at chaotic collections of gas and dust. We are witnessing the fleeting, glorious bloom of the entire universe. To truly grasp the immense significance of this, we must patiently trace the invisible, unbreakable thread that connects the massive, dying galaxies to our own fragile, beating hearts. The brutal truth is that our very existence is entirely predicated on the ancient deaths of countless stars. Every single breath you take draws in oxygen that was violently forged in the final, agonizing moments of a massive sun collapsing under its own relentless gravity. The iron that bravely carries that oxygen through your veins was created in the terrifying crucible of a supernova explosion, a cataclysmic event so unimaginably powerful that it briefly outshone entire galaxies before scattering its precious, life-giving elements across the silent void. The calcium that forms your bones, the carbon that forms the fundamental structure of your cells, all of it is the direct physical legacy of cosmic death. We are literally a physical manifestation of the universe's ancient past, beautifully organized by billions of years of blind, unguided evolution into complex structures capable of experiencing love, feeling wonder, and asking profound questions about our origins. We are, as the great astronomer Carl Sagan so beautifully observed, a way for the cosmos to know itself. We are stardust that has miraculously learned to think, to feel, and to patiently record the passing of deep time. Every single telescope we build and point toward the heavens is simply an extension of our own curious eyes, a highly advanced tool constructed from the very elements of the earth to gaze back at the celestial origins of those same elements. Through these remarkable instruments, we transcend our biological limitations, casting our vision across billions of light years of empty space to read the faint, ancient light of dying stars as if it were a grand, cosmic history book written exclusively for those willing to patiently learn its language. This gentle realization fundamentally changes exactly how we must view our place in the infinite dark. We are not insignificant, isolated creatures hopelessly stranded on a tiny rock floating in a cold, uncaring void. We are the universe itself, finally awakening after billions of years of silent slumber to gaze back at its own magnificent reflection. The capacity to feel awe, to patiently unravel the complex laws of quantum physics, to carefully measure the distance to a galaxy situated 1 billion light years away, is the absolute highest expression of the universe's inherent potential. We do not need to conquer the stars to be significant. Our profound significance lies exactly in our miraculous ability to gently understand them. The quiet, ancient universe will eventually, inevitably, fade into eternal darkness as the last red dwarfs exhaust their fuel and the supermassive black holes evaporate into nothingness. But the undeniable fact that it was once fully understood, that its breathtaking beauty was once truly appreciated by a conscious mind, is a glorious triumph that can never be completely erased from the fabric of existence. The brutal truth about death is that it is the ultimate, necessary frame that gives the painting of life its beautiful meaning. Without the absolute certainty of an ending, the gentle moments of our lives would lose their precious, fragile urgency. It is the very fleeting nature of our existence that compels us to seek meaning, to connect with one another in the dark, and to reach out into the unknown in search of deeper understanding. When we bravely confront the ultimate fate of the cosmos, the long, slow decline into maximum entropy, and the final heat death of the universe, we are given a profound, invaluable gift, the gift of true perspective. All of our earthly anxieties, all of our petty conflicts and superficial desires gently dissolve into nothingness when placed against the staggering backdrop of eternity. What truly remains is a deep, abiding sense of peace and a profound, overwhelming gratitude for the simple, miraculous fact that we exist at all to witness the splendor. The silence of the universe is not a menacing absence of sound, but rather a comforting, quiet sanctuary where the mind can safely wander across the galaxies. It is a meditative silence that invites us to listen closely to the ancient whispers of creation, to find solace in the mathematical perfection of orbital mechanics, and to feel a profound kinship with every other conscious being who has ever looked up at the stars and asked why we are here. Our shared pursuit of knowledge is a noble, multi-generational journey that binds humanity together across the centuries, a collective effort to build a cathedral of understanding out of the raw materials of observation and reason. As you lay your head down to rest tonight, I invite you to close your eyes and picture the vast, silent ocean of the cosmos. Imagine the trillions of stars burning quietly in the dark, the massive, elegant spirals of distant galaxies slowly turning in the void, and the invisible, powerful currents of gravity gracefully shaping the grand structure of reality. Feel the slow, steady rhythm of your own heart, and realize that it is beating in perfect, quiet harmony with the ancient, eternal rhythms of the universe. You are safely, securely held within the gentle embrace of physical laws that have remained perfectly constant since the dawn of time. There is absolutely nothing to fear in the dark, for the dark is simply the quiet, peaceful canvas upon which the magnificent, brilliant story of light is beautifully written. Our journey together through the mysteries of IC 1101 and the ultimate fate of the universe has finally come to its natural, gentle end. But the grand, infinite journey of human discovery will continue as long as there are curious minds to look up at the sky and wonder. The universe is endlessly generous with its marvels, always ready to reveal a new secret to anyone who patiently takes the time to ask. When you next look up at the night sky, I want you to remember that the same quiet forces that govern the majestic dance of the largest galaxy ever discovered are actively working within you right now. You are a breathtakingly complex, transient masterpiece of biology, standing on the shores of an infinite cosmic ocean, possessing the extraordinary ability to comprehend the very mechanics of the abyss that surrounds you. Thank you for sharing this quiet, contemplative space with me, for opening your fragile mind to the staggering vastness of the cosmos, and for bravely facing the brutal, beautiful truths that lie hidden in the ancient stars. May you carry this deep sense of cosmic peace and gentle wonder with you in all your earthly days, forever remembering that you are an integral, beautiful part of this magnificent, infinite masterpiece.